Good morning to everyone.
Good morning.
Good morning, sir.
Good morning.
We at Ramco Institute of Technology have endeavored to host the first international conference on sustainable technology in civil engineering and applied sciences, ICSTCA 23. Sir, can you hear me?
Yes, I can hear you.
Yes, sir.
Shall I?
Thank you, sir. First International Conference on Sustainable Technology in Civil Engineering and Applied Sciences on 24th, 25th March 2023. We are very delighted with the overwhelming response we have received from academicians, scientists, researchers, industry experts, UG PG students, and research scholars who have agreed to exchange and share their research findings and solutions on all aspects of civil engineering and applied sciences. The main purpose of this conference, ICSTCA 23, is to look ahead towards growth and sustainability. This conference has brought together approximately 60 participants who will be deliberating on the use of sustainable technologies to address the global issues. We at RIT are committed to provide a good platform to discuss the scope, importance, and need for employing sustainable engineering technologies in civil engineering and basic sciences. We take this opportunity to thank our chairman, Sri P.R. Venkatramaraja, for his inspiring support towards the organizing this conference. We also thank our patrons Dr. R. Venkatraj, CEO, Ramco Educational Institution, and Dr. L. Ganesan, Principal, Ramco Institute of Technology, for their guidance. My thanks go to our co-patron Dr. S. Rajakarnagaran, Vice Principal, for his suggestions and help. We take this opportunity to acknowledge the tireless efforts of the conveners Dr. S. Dharmar, HOD Civil Engineering, and Dr. K. Pasarikudi, HOD Mathematics, National and International Advisory Committee members, faculty coordinators of all the departments, and the faculty of RIT. We thank them with all my heart. We also thank all participants for being part of this event. We are sure we will have an interesting and fruitful time deliberating on the smart tools, devices, and technologies. Thank you.
Good morning to one and all present here. Myself, Dr. G. Karthikeyan, Assistant Professor, Senior Grade, Department of Civil Engineering, Ramco Institute of Technology, Rajapalayam. I would like to express my great pleasure and welcoming all of you to this international conference on sustainable technology in civil engineering and applied sciences 2023 ICSTCA, which is sponsored by TechApps Consulting, Chennai, Modern Scientific Coimbatore, AIMIL, Intest Instruments, Pyramid IS Academy, and Sendur Builders and Traders, and organized by Department of Civil Engineering, Ramco Institute of Technology, Rajapalayam. It's my privilege and honor to welcome today's chief guest for this international conference, Dr. Muhammad Al-Azlala, Assistant Dean of Scientific Research, Department of Civil Engineering, Aqaba University of Technology, Jordan. He is a person with a rich teaching and industrial person. It's an honor to have him. I welcome you, sir.
Thank you. Thank you, sir.
Now, I would like to introduce chief guest brief profile. Dr. Muhammad Al-Ghazlala, Professor Assistant, Dean Scientific Research of Aqaba University of Technology. Dr. Muhammad Al-Ghazlala received his PhD in Civil Engineering, Soil Mechanics from Georgia Assoc Technical University of Iași, Romania, 1988. He is having total years of experiences 32 years, in which 7 years in Al-Baqa Applied University, Jordan as Assistant Dean of her Academic Affairs, and 23 years in Sultanate of Oman as Head of Engineering Department, Initiative of Civil, Architectural, Land Surveying, and GIS and Petrochemical Engineering programs for the first time in Oman, and 2 years in Aqaba University of Technology, Jordan as Assistant Dean of Scientific Research. He was nominated 4 times as external examiner for Indian universities for evaluation of PhD thesis in civil engineering. He was selected as one of the member of advisory committee for international conference on sustainable technology in civil engineering and applied sciences in RIT. His research interests include civil engineering topics, soil mechanics, foundation structures, soil reinforcement, GIS, land use, urban planning using RGS, climate changes, water uses, and renewable energy. He has published more than 25 research papers in international conferences and journals. He was invited as keynote speakers for more than 5 international conferences. He was awarded as the best lecturer in Sultanate of Oman in the year 2019 and 2020. So with this brief introduction, so I once again welcome you, sir,
Thank you, sir.
for this international conference.
Yes. May I start?
And thank you, sir. You can start the session, sir.
Okay, I will share my presentation.
Thank you, sir.
Is it visible?
Yes, sir. It is visible, sir.
Okay. Thank you, Dr. Jinasyan, Principal of Ramco Institute of Technology. Thank you, Dr. Darmar, Head of Civil Engineering. Thank you all who invite me and who contact through the WhatsApp, through emails with me. Thank you for all colleagues and friends who chat with me during the couple weeks. Thank you for inviting me to this wonderful international conference and for giving me the opportunity to talk about the sustainability technology in civil engineering. Distinguished audience, every day large scale of projects are being put into action to innovate and repair infrastructure and resources in everywhere from the world. Sustainability in civil engineering practices forms the backbone of modern project planning and management, allowing experts to ensure that each project is conducting using the safest, most environmentally friendly, and long-lasting method available. Using research and innovation, civil engineers can incorporate new and sustainable methods that both cut down on emissions during the project and extend the lifespan of completed projects, saving resources on repairs and reconstruction with over thousands million miles of highway in any country, even in some region here and there, and that and securing that projects such as paving infrastructure are completed efficiently has significant financial and sustainable impact. Sustainability examples, I will give you some examples, methods to increase sustainability practices in civil engineering. So I can say that water treatment resources, one of the most important today, and it will create challenge to maintain the sustainability. The pollution reductions, again, second thing which is very important for us, for our life, to live in a healthy way. Innovation in renewable methods and materials. This is again challenge for civil engineers to start to be innovative and creative and to use the renewable resources. Benefits of sustainable constructions promotes healthier living for our life, reduce the waste. We can see every day the waste everywhere. And this is the main challenge for a human being. Boosts the economy, so it will enhance the economy. Promotes cost efficient, decreased material cost, enables carbon footprint reduction, so it will reduce the percentage of carbon in the air. Today, we can see the pollution everywhere. and the effect of our health because of the pollution and the environment. It is challenging us as civil engineer, as doctors, professors, students, everywhere, even for others. So we need to think and deeply how we can minimize these things. Let us to go for some application of materials in, like for example, the type of pavement where the recycled materials used there, where the sustainability is required. So if we go for any road, we can see that it is flexible, rigid, composite. So the three main materials used in paved roadway, so are the reclaimed asphalt pavement, ground tires, rubber, which is comes now in very fast way. People, they are using tires everywhere in order to increase the strength of the soil layers, or even to be added to the asphalt. And recycled asphalt, again, it is used. Reduced pollution, how we can share the word with our experience, how we can reduce the pollution. Increasing the efficiency in both construction of a project and materials that being used help reduce pollution and long-term environmental impact. Using more efficient methods during construction can shorten the time, resources, pollution emitted during the development of a project. Considering the large number of projects undergo each year, this increased efficiency plays an important role in both the sustainability, infrastructure, and the cost. Can you hear me, please, all of you?
Yes, sir.
Is it okay?
It's okay, sir. You can continue, sir.
Yes, I will continue. Thank you. Using renewable resources, how we can use the renewable resources and from where we can take them. As the population grows, we know everywhere, every country, the population, number of population is growing very fast. As the population grows and the infrastructure already in place age, there is need to build roadways and resources as well as their repair, the bridge, tunnel, and others. So sustainable in civil engineering practices can improve industry standards and lessen to the environmental impact by transitioning to the affordable and sustainable materials. Renewable resources may also be longer lasting, requiring less frequent repair and saving money and resources over the long term. Sustainable development, the area in need of multilateral solution. So as civil engineer, we should be the we should play the major role in this regard. So constructing with the sustainable materials is not only good for the planet and common sense, it can save the client money. So we can save the client money everywhere. So help preserve our heritage, respond to planning policies. A sustainable material is one that does not deplete non-renewable resources, has no adverse impact on environmental when it is used. So sustainable technology materials and products, which are the sustainable material most widely used for construction? This is the big question for us. So sustainable material and building material, like for example, timber is the material with the lowest environmental impact. So we can take conclusion that we can enhance the usage of timber in construction, in buildings. So on its production and life cycle, and has to be certified. So that we can be sure about its sustainable production and origin. Isolation, renewable materials, even in as civil engineering, we know that we are using material for isolation. So the isolation renewable materials, these are completely recycled and compositable. So here recycling comes under isolation materials or even sustainable building materials. Which recycled material can be found? There is a resource of waste. So we can see that once we demolish any building, we can see a huge quantities of material that comes after demolishing any building. So we could go for recycling those material, construction material. We can extract good materials and to be reused again. I will give example here about the waste tires industry in road construction and other application like green roads, we call it today, green roads. Use of waste materials in road construction. As introduction, I'll give you such important for this issue as in Jordan generates more than, even in India, you have more than this. You have 100 million of tires. So we have in Jordan around 10 million scrap tires every year thrown here and there in the land, and it will affect and it will impact the environment and it will create pollution for our life. So we can go for like project as civil engineering students can take it, and the engineers, they can go and they can enhance the methodology of using the tires by extracting rubbers. And we know that today the rubbers is very expensive. And last time our friends from Qatari state, they consume more than 1 million meter square tiles for sport areas from extracted from tires recycling by taking the rubber powder and producing healthy rubbers tires. So recycling comes first, then reduce pollution. So this the goal for any project. While you are going for reuse the material, you will recycle and you reduce the pollution, and you will take some benefits to your local community. You will serve your even human life. So if I take example in the world as example, as the major issue is the most major tire related to the fire in the world due to the tires thrown here and there or kept in any store which where is no any safety there. So if in this table it will show and it will give us challenge how we can minimize the fires in the world and minimize the impact on the pollution in the environment. By recycling tires is dedicated to reducing the amount of tires that occupy our landfill. In addition, benefit to environment, use tire recycling can be profitable business. Even I can give an example of my students in Sultanate of Oman before 5 years. They start with, I was the supervisor, they start with small project by constructing a small company in order to deal with the waste tires in Oman. And now I can say in Oman, my students, my graduates, my alumni students, they have income more than $5 million per year from the recycling the tires, and they have their own company, and they have one branch in Abu Dhabi and Dubai, and they are producing from tires rubber powder, which is very expensive today. And we know that China, they are leading the world with the quantities that they have. And if you advise your students to go for recycling the tires in different ways, even they can innovate new ways, new methodology how to deal with the recycling of tires, waste tires. Usage of waste tires recycled. Road industry, for example, this is the application area. Road industry, plastic industry, automobile industry, sport areas, and agriculture. Even in agriculture today, instead of soil, clay, they are using rubber powder, and it will be, because the rubber powder, it is not heavy like the soil. It is used and it is maintained the water content. I can give example of the tiles produced from rubber powder. This tile can be used in sport areas and in the hospitals, corridors, and the ICU rooms. Today, it's compulsory to use it in the hospitals and in the to give isolation of sound and to give stability for staff nurse and doctors who are walking in the corridor in the room. They will not fall down. They will not sliding down. So this, it will give isolation plus stability in by using the tiles in the hospitals. And today, one of the requirement in the hospital that it's compulsory, they have to use the tiles from rubber powders. And if you look in this sport area, again, where the sport area and everywhere, they cannot get ISO unless they have to use the rubber and the healthy rubber powders as tiles as other products to use in sport. And we can see from Qatar state that they have used a huge quantity last year for football and their stadium and their sport areas. The rubber material produced from tires and its size range from 1 up to 4 millimeter. Among the engineering application in which rubber is used are rubber asphalt. Here, we can use it in asphalt. We can mix it with the concrete, with the asphalt, and we can enhance the concrete today, and we can call it RAC, rubberized asphalt concrete. Here you can see as example, I give the color. You can add it to the rubber, even to the extracted from waste tires, and you can give any color you wish and you like. What is the goal of using the rubber? Here, usage of waste tire in industry, especially in railway, even not only to increase the strength or to make to preserve the water content, not only, it is giving one important issue, which is it will decrease the sounds come from railway. So it's play a role of isolation sound, phonic isolation sound. So the usage of tire cycling in railway infrastructure, it is used everywhere. Spain, even in Jordan, Spain, and in UAE, in Oman, and everywhere in India, it is used, and it is decreasing, minimizing, decreasing the vibrations due to the railway. Opens new market, new business for our civil engineer, our alumni, our students who will be graduated. They can think they can open their own construction material shop with the rubber tiles and rubber powders and tires. We can see an example here, the United States of America statistics for the recycling and rubber used, and they are extracting fuel. They are extracting fuel from rubber, from the waste tires. They are extracting even rubber powders and others. So tire crump, which can be added to the soil layers under the highway and the railway. Here we can see the problem that we face in our design. Once we construct, once we implement our project in railway and highway, we found that we have a lot of problem with the existing asphalt and bitumen mixed. But if we think in how we can enhance the mixing the rubber with the waste tires with the bitumen, with asphalt, with the pavement, with the soil layers, then we can enhance the properties and we can get good benefit for that. And you could assign to your students some small project in order to ensure that they can get benefit from using off-waste tires. Here, the rubber, it shows that in practice, it is look very nice and effective. It give efficiency to the railway, highway, roads, everywhere. The benefits from of ballast mixed with the crumb, even low performance cost, environmental protection, and non-blocked line to run. Here, the recycling equipment, I will show you that we start from collection, transportation, sorting, shredding, steel removal. We remove the steel wire from the tires, gridding and finished product, testing and distribution, and getting here the samples and quality assurance from the quality of materials. Here you can see the rubber mat here and car mats. It's used in everywhere, in every factory of cars, car mats and mouse pads we can see, and carpet, and we can see even in other usage, and even we can recycle the tires in different ways, and we can assign these things for small projects for our students, and they can get benefit from the usage of the waste tires. Here we can see how the rubber granulars are added, and even rubber waste tires, small pieces added to the pavement, and we can see and we can test the project after the usage of this mixing, and we can take samples from any project after construction, and we can get and we can ensure that it will enhance a lot of properties. Any question, please? Any question? Hello?
Any questions from participants, presenters? I request the participants, any questions?
If no, I am thanking you, Doctor. Okay, Doctor.
Uh,
Yes.
Sir, we had an excellent session, sir, and I take the honor of proposing the vote of thanks for this session, sir. I wish to extend my heartfelt thanks to Dr. Mohammed Al Ghaslala, sir, Assistant Dean of Scientific Research, Department of Civil Engineering, Aqaba University of Technology, Jordan, for accepting our invitation and for being the chief guest for this international conference and deliver the talk on overview on material recovery and recycling of waste tires, for addressing the research scholars, faculty members, and students. Once again, I thank you, sir, for spending your valuable time with us and
You're
sharing.
welcome, sir. I am ready for your institute. I like your people who cooperate with me. It is almost 4 years ago. Yeah, thank you.
Yes, sir. I wholeheartedly thank our
Just
principal,
allow me
Dr.
to
L.
thank you. Yeah,
Yes, sir. Dr. L. Ganesan, sir, for his support and guidance for arranging this international conference. Also,
yeah,
I thank uh, our beloved HOD, Dr. S. Dharmar, sir, and the faculty members of our civil department for
sure,
our
sure.
valuable suggestions and help. And also I thank Dr. Indumadi and Dr. Venkatesh Perumal for organizing secretary for this international conference. So finally, a big thanks to all the faculty members and the internal and external participants from various institutions. So we hope you benefited from this today's invited talk, and also the next session will going to start for the presentation at 11 o'clock. I wish you all success to all the participants. Once again, I thank everyone present here for this international conference. So thank you all. Thank you,
Thank you,
sir.
thank you, thank you. Thank you,
Thank you.
sir.
Thank you very much, sir. Thank you.
Thank you.
The following keynote address is going. Dear participants, kindly fill the feedback link posted in a message box. Dear participants, let us start the keynote address.
Good morning to one and all present here. It gives me immense pleasure to say a few words regarding our keynote speaker for our first international conference on sustainable technology in civil engineering and applied sciences. First of all, I would like to thank Professor Dr. Fasto P. Garcia Marcus for his acceptance to deliver the keynote address through online mode. Professor Garcia worked at UCLM as a full-time professor in Spain. He was an honorary senior research fellow at Birmingham University, UK, a lecturer at the Postgraduate European Institute, and he has been a senior manager at Accenture during the period of 2013 to 2014. He obtained his European PhD with maximum distinction. He has been distinguished with these prizes: Nominate Prize, Grand Master in 2022, Grand Prize in 2021, Runner Prize and Advancement Prize in 2018, Silver during 2012 by the International Society of Management Science and Engineering Management, and also in the first International Business Ideas Competition 2017. He has also published more than 240 papers. Some remarkable articles are Applied Energy with an impact factor of 9.746, which is also awarded as a best paper during 2020. He also published articles in renewable energy with an impact factor of 8.001, which is awarded as a best paper. Then ICM SEM as excellent paper. And the last one, International Journal of Automation and Computing, which was the most downloaded article. Like that, there are so many articles he has published. He is the author and editor of more than 48 books in Elsewhere, Springer, Pearson, McGraw-Hill, Intech, IGI, Marcombo, Alpha Omega. He also authored more than 1,000 international chapters and 6 patents. He is the editor of 5 international journals and as a committee member for more than 70 international conferences. He has been the principal investigator in 4 European projects, 8 national projects, and more than 150 projects for universities and companies, etc. His main interests are artificial intelligence, maintenance, management, renewable energy, transport, advanced analytics, and data science. With this few introduction, let us proceed with his keynote address. So now I will share the recorded video of the keynote address.
Good morning to everyone. Thank you very much for this opportunity to participate in the International Conference of Contemporary Research Advancements in Mechanical Engineering, held by the Department of Mechanical Engineering from Ranco Institute of Technology from Raja Palayam in Tamil Nadu, India. Especially thank you very much to the chairman, Professor Venkatramana Raja, and also to the organizers to consider me for this conference. One of the main topics that you are covering here in this conference is not only mechanical engineering, but you have also one big topic called it thermal. In the thermal, you have renewable energy systems, and also you have another important topic covered in this conference, that is artificial intelligence. My speech of today is about the artificial intelligence applied to renewable energy system, especially when we are talking about maintenance. Okay. Artificial, and then I will finish trying to solve and to give to provide the answer between the relationship between artificial intelligence and energy, especially when we are talking about maintenance, that the mechanical engineering is a very, very, very important topic. First of all, I will introduce to myself. I'm professor at Castilla-La Mancha University. This is a university from Spain, located in the city center, close to Madrid. Spain is in the south of Europe, north of Africa, and I'm leading here a research group, international research group, where we are working now in different international, national, and regional projects, where the main idea is to develop different research with this financial support in collaboration or not with different companies and different universities in the along the worldwide, and then different collaboration with many people from the world, especially from India. We are also doing teaching activities. Our main objective, of course, is to publish from these research projects, etc. According to that, we have got different international prizes and awards in the last few years. And this is mean that maybe we are not doing bad things, no, bad research. Introductions. I will introduce AI for people, artificial intelligence for people. This is the first multi-stakeholder forum bringing together all actors interested in shaping the social impact of new application of artificial intelligence, including the European Parliament, civil society, organization, industry, and the media. This is an organization here in Europe focusing on artificial intelligence. 6 months later, the European Commission established the high-level expert group on artificial intelligence, where I'm expert on this group, of this high-level expert group. There's different groups for the main key points that you can find in this slide on the bottom: automotive, banking and finance, energy, healthcare, etc. I'm part of or member of the energy. According to that, Europe and the different countries of the worldwide, along the worldwide, you can see that they are beginning to work in the strategy on artificial intelligence around 2017, 2018. The roadmap of these strategies is about more or less 3-4 years, and they are extended that, this strategy, and there's a general consensus according to this strategy from the different countries. But what happened with this strategy? Because you see, for example, here in this slide, there is many different strategies according to the different countries. So from the beginning, from this strategy, we can find different definitions of artificial intelligence. Okay, and then when we are talking about artificial intelligence, maybe we think always that is far away, from mechanical engineering, because it's more close, for example, algorithms, software, etc. According to the European Union, the definition of artificial intelligence say that artificial intelligence refers to systems that display intelligent behavior by analyzing. The first question here is what intelligent behavior, okay? Because intelligent is a very ambiguous word. If we want to talk about intelligence for humans, we know that from one person to another person, the intelligence is different. So it's very ambiguous, this term. Intelligent behavior by analyzing their environment and taking actions, with some degree of autonomy. How much degree? It's ambiguous also, to achieve specific goals, specific objectives, on that. Artificial intelligence-based systems can purely software-based, that this is what we have usually in mind, but also here they refer that artificial intelligence can be embedded in hardware device. So here we can see the importance of artificial intelligence in mechanical engineering. It's a very important issue. Concretely, the artificial intelligence, the origin with Alan Turing is in mechanical, not in software origin, the origin, no, of artificial intelligence. No? And from here we can see also different definitions. So the first conclusion from this slide is that we have different definitions of artificial intelligence according to the strategy that we can have like a reference in the around the worldwide. No, so we have as much definitions as strategies we have. No, more or less they are going in the same direction, no? But they are not the same. Yeah? What happened with the international standards? The most important are the ISO and the IEEE. No? And here we can see, for example, the ISO, and they are standard that most of them are ongoing. Ongoing means that they are different group, expert group that they are working on that. So they are setting this the standard. One of the most important standard is where they fix the definition of artificial intelligence. So here in this standard, we can find a new definition of artificial intelligence. But if we go to IEEE, it's exactly the same to ISO. We have different standards. They have the one main standard. Most of them are ongoing, and they have one standard that you can find the definition. So here we can find another definition. So when the people ask you what does it mean, artificial intelligence? The answer is depend, no, according to this standard, to another standard, to this strategy, to another strategy, etc. No, so we have many definitions about the same terms in the worldwide. No. I would like to clarify that from ISO and IEEE, when we have this standard, then the different countries, they extend and they copy and paste this standard to the different national standard or another international standard. So they are the main reference in the worldwide according to that. We need to think that from this different strategy, what they are doing, the countries are doing, is then to fix. First point is the ethic, according to the artificial intelligence, but then they are working in the liability of the around the artificial intelligence. So the laws according to that. And this is very important because in mechanical engineering, when we are doing any group, any work, sorry, any project or something like that, and we apply artificial intelligence, we need to sign a contract, no? Because we provide a service for money, for example, no? But what happened with the responsibilities according to the artificial intelligence? The responsibilities is according to the different standards and the different laws. So we need to have this standard and these laws in order to have reference, in order to fix responsibilities for sign any contract with regards to any topics of the artificial intelligence. So here we have seen the importance of the laws and the standards for mechanical engineering when they are employing artificial intelligence in any of the projects. I will talk about artificial intelligence and energy now in order to focus my speech now in renewable energy, because we need to have clear enough that in the worldwide in general, the most important topics are artificial intelligence and also renewable energy, because renewable energy is changing now the industry of the energy, and this is very important for the mechanical engineering because they need to develop new mechanical system, idea, device, etc., in order to apply this device mechanical system to this industry. No? Here in this slide, if we analyze the research paper published in Scopus in the last few years, we can see the general trend. The shape is not continuous, but this is very simple to understand that, because when we write a paper, for example, 1 year, maybe the paper is published in 2 or 3 years, or maybe we can get 2 or 3 papers together because one was accepted this year and one was coming from 1 or 2 years ago and was accepted in this year. So we can see here the reason of that the shape is not continuous, but the idea of this slide is to see the general exponential trend of the publication. And here I would like to mention 2 words. No? One is research, one is innovation. Here we are talking about research, but research after that is transforming to innovation, because innovation is coming always from the research. So if we analyze the research, we know what is the way of the innovation. The innovation are the new solutions in the industry. So here we can see the exponential trend in the new solutions when we consider the artificial intelligence applied to this new industry of the energy based on renewable energy sources. No, here's in general, but I will talk later about renewable energy. If we analyze by country, we can see, for example, the importance of countries like China, that is leading in the last year this research, also India, US, and also Europe. Europe, if we see here in this slide, we need to zoom the different countries like Germany, Spain, Italy, France, and then we can see, for example, that when we zoom over these numbers, we are in the same position like India, US, and China. But here we need to clarify that, for example, China and India, they have more population than other countries. So it's normal that they generate more publication because there is more people living in these countries. No, if we compare that, for example, India with more than 1,000 million people living over there. In Spain, we have 48 million people. No, so it's too much different. No, populations living in the different countries. What are the main topics? If we see here the main topics covered by the artificial intelligence, when we apply that to energy, is more or less the optimization of the resources in one way. Another way is renewable energy sources, no? Especially when we are talking about solar energy and wind energy. They are the most important topics, okay? What are the main methods? But here we can see different methods based on artificial intelligence for learning system, neural network, methodic's algorithms for optimizations, etc. So also the algorithms for the academia is very, very familiar for everyone. Sustainability and renewable energy. I will focus now in Europe, but you can extend that conclusion to any countries of the worldwide. We can see in this slide that the economic is rising, but the gas emission is reducing because we employ or we are replacing here the conventional energy sources by renewable energy. But this is not the end. So the idea is to extend this politics and these strategies in the next few years, especially now when the crisis or the war between Russia and Ukraine, Europe has been affected, you know, by the energy sources coming from Russia, because there is a big conflict now between Europe and Russia, and then Europe want to accelerate the development of renewable energy in Europe. No? But according to the white paper, you need to have clear enough that the strategy from Europe is focused in sustainability and also in artificial intelligence or digitalization of the industry, no? But not in any way. You need to guarantee to the industry and the society the security, accessibility, and reliability, no? In order to develop and to use this type of new strategies, no? The digitalization and also the green transformation of the energy sources and the industry, no? And here we can see the opportunity for business, no? For the investment in green energy in 2005, it was $88 billion. In 2018, it was 332 billion of dollars. And then here, according to the Applied Energy Symposiums, they say that we are in the middle of the revolutions and is expected more than inversion more than or close to 3 trillions in green energy sources. No, the roadmap to 2050 for Europe is to reach the 97% of renewable energy by 2025, but they are talking now about 100% and earlier than the 2050. So here we can see the great opportunity for mechanical engineering in this new industrial revolution that we are experimenting not only in Europe. I'm talking about Europe, but you can extend this conclusion for any other country around the worldwide. I will focus now about wind energy. The wind energy is very, very simple, the importance of wind energy, because when we are talking about renewable energy sources, so what is the most popular renewable energy? The answer is very, very simple. It's the most attractive for the industry. The most attractive for the industry is the renewable energy that will provide more profits for the industry. No? At the moment, it's wind energy, but now, for example, the investment cost of photovoltaic solar power plants are getting cheaper, and then they are getting more competitive with regards to the wind energy. And then the industry of wind photovoltaic solar power plant is increasing. No? So it's very, very simple. No? But I will focus, I repeat, about wind energy. Wind energy, it's very simple. They will create a new specialist jobs with specific profiles, especially for mechanical engineering. So there is a great demand of that. The idea is to increase the business in order to reduce the cost of maintenance and operations of this type of industry, because the sources are very cheap at the moment, is the wind. And they want to increase the reliability and ability of this type of system. How can you increase that? Increasing the maintenance management, because you have now new sensors, the new communication system, new algorithms for analytics, etc., that you can employ in this type of industry. So here we can see, for example, that we have in maintenance the outlook to 2025, a growth annual trend of 11% to reach $28 billion. No? So here we can see also the great opportunity for this topic, and this topic is one of the most important for mechanical engineering. And I was mentioned that it's possible because we are applying new sensors, new communication system, so they are reading more data. Here, for example, we can see the data volume of the data. That is, it was 33 zettabytes in 2018, and it's expected to reach 125 zettabytes in 2025. In general terms, this is 4 times the volume of Twitter, for example. No? And here, according to the Applied Energy Symposiums, they are talking that is expecting 6 trillions of investment in this type of dollars in this industry, and it's expected to more and more investment in this topic. So this is a very important topic for any mechanical engineering at the moment. And this is the general idea for the main industries. I'm talking about General Electric, Vestas, EDP, and Siemens. No? Here we can see that they are monitoring most of the device, most of the wind turbines, most of these. Now, for example, this industry is going from onshore to offshore. So it's more important, this type of device, because the wind turbines are beginning more complex and larger. No? So this is more and more important. I will finish the conclusion because when they ordered me to prepare the conference, they ordered me to be speaking for 20 minutes. Now I'm talking for 22 minutes, so I'm very sorry for these 2 or 3 minutes. Conclusion: there is no international consensus about the artificial intelligence. Artificial intelligence must be developed according to the ethics and liability of every country. New standards are ongoing, mainly ISO and IEEE, and from this standard we will see that then the other standard we copy and paste and modify this standard in order to adapt to the different national standards. Then energy management depends and will depend more of artificial intelligence. The energy future is about sustainability and renewable energy. I was mentioned about the case of Europe, but we can extend also for this case of any country in the world. And wind energy will be one of the most used renewable energy, together with the solar, especially for photovoltaic solar energy. again to organizers of this excellent conference. I wish you all the best for this conference, and I hope that if you have any question or something like that, you can contact me by email that you can find here in the slide or in my homepage on the social networks like Twitter or LinkedIn. And any of you is interested in any collaboration or anything, please feel free contact to me. And thank you very much again. Thank you.
I really thank the keynote speaker for his nice delivering. If you have any queries, you can contact the keynote speaker using this mail given. Now I also request the participants to post your feedback, which will be posted in the chat box. Thank you. So after a small break, the session will start.
Good morning to one and all present here. Myself, Mrs. R. Kalaimani, Assistant Professor, Department of Civil Engineering, Ramco Institute of Technology, Rajapalayam. On behalf of Ramco Institute of Technology, I would like to express my great pleasure and welcoming all of you to this first session of International Conference on Sustainable Technology in Civil Engineering and Applied Sciences 2023. It's my privilege and honor to welcome Dr. Ravi Sir, Associate Professor, Department of Civil Engineering, MEPCO's Link Engineering College, Sivahasi. The session chair for this session. Mrs. Lima Market Madam and Raghavan Sir, Assistant Professor in Department of Civil Engineering in Ramco Institute of Technology as internal chair. Now I invite Mr. Raghavan Sir to give you a brief introduction about our session chair.
Good morning, everyone. The Professor Dr. A. Ravi is currently working in MEFCO's Link Engineering College, Sivahasi. Hold his PhD in Civil Engineering from Anna University, Chennai in the year of 2022. He has completed Bachelor's in Civil Engineering at MS University, Baroda in the year of 1997 and a Master's in Construction Technology and Management, Rajiv Gandhi Proud Yogiki Vishwavidyalaya University in Bhopal, Madhya Pradesh in the year of 2003. He has 15 years teaching experience in MEFCO's Link Engineering College since from the year of 2007. Currently, he is working as an assistant professor in the same college. He has more than 20 years of experience in industry as competent member in Indian Air Force from 1987 to 2005 and instructor in Indian Air Force from 2005 to 2007. His research areas includes concrete technology, sustainable materials and concrete, special concrete, geopolymer concrete, construction technology and management. And he has published more than 5 international journals, 10 international conferences and 5 national conferences. His project, development of novel and cost-effective engineered cementitious composite members for seismic prone areas, was awarded a grant from the Institution of Engineers for rupees 45,000. AICTE Modrops awarded a grant of rupees 12 lakhs for the establishment of durability testing facilities in a concrete laboratory. AICTE RPS awarded a grant of rupees 8 lakhs 90,000 for the development of geopolymer concrete based on autoclaved fly ash for precast and pre-stressed structural parts. He is a member in the Institution of Engineers, a member in the Indian Concrete Institute, and a member of Indian Geotechnical Society and Project Management Institute and the Indian Society for Technical Education. Once again, I welcome you, sir.
Thank you, sir. Before starting the session 1, I would like to share few instructions to the presenters. Time for each presentation will be 10 minutes. 3 minutes is allotted for questionnaire. So make sure that the slide for your presentation which can be completed within 10 minutes. You are requested to follow the timing allotted strictly. Our moderators will give you alert message or signal for time left. Strictly, the allocation of time must be followed. Don't interrupt or create any sort of audio or visual disturbance to other participants or presenters. If you are having any doubts or facing any issues, kindly share that in chat box. When the questionnaire session has started for a particular batch, next presenter should be ready with their presentation. You can close the presentation only after the moderator's announcement. Once you finish the presentation, you need not to be present in the online platform. However, based on your interest, you can listen to other presentation too. The link for the feedback will be displayed at the end of the session in the chat box. For getting certificate, the feedback is mandatory. The certificate will be sent to your mail ID after verification within 3 to 4 days after the conference. Ravi.
Actually, madam.
Yes, sir. Yes, sir. Shall I start, sir?
Should I unmute mic or it should be in mute condition?
Sir.
நான் மைக்கை வந்து நான் ஆன் பண்ணட்டுமா இல்ல ஆஃப் பண்ணி வச்சுக்கிறவான்னு கேக்குறேன்.
நீங்க ஆன் பண்ணி வச்சுக்கலாம் சார். நீங்க क्वेश्चन கேட்கும்போது மட்டும் ஆன் பண்ணிக்கலாம் சார்.
ஓகே ஓகே
ஓகே சார். ஓகே சார். ஓகே சார். थैंक यू சார்.
வீடியோ தேவையில்லை இல்லையா?
வீடியோ தேவையில்லை சார். தேவையில்லை.
ஓகே ஓகே.
ஓகே சார். ஓகே சார். Now I invite paper ID C001 to present your paper. Arun Siddharth, sir.
Yes, ma'am.
Can you share your presentation, sir?
Sure, ma'am. Sure.
Okay, sir. Okay, sir. Thank you, sir.
Is my screen visible? No, ma'am. Am I visible, ma'am? Is my screen visible, ma'am?
No, sir. No, sir. Share your presentation, sir.
Ma'am, is it visible,
Now
ma'am?
it's visible, sir. Visible, sir. You can proceed, sir.
Okay.
Okay, sir. Thank you, sir.
Ma'am, is the audio visible?
Yes, sir. Audible, sir. Arun Siddharth, sir.
Ma'am. Hello, ma'am.
Yes, sir.
Ma'am, you have called me.
Okay, sir. Okay. Arun Siddharth, sir.
Yeah,
Sir.
ma'am.
Sir, present your PPT, sir.
Ma'am, is it not visible, ma'am?
Sir, is it visible, sir? Visible. Your presentation is visible, sir.
Okay, ma'am.
So you can present, sir.
Ma'am,
Sir, you can read your presentation, sir.
ma'am, just a minute, ma'am.
Okay, sir. Okay. Your voice is not audible, sir. Your presentation is visible.
Okay, ma'am. Okay, ma'am. Just a
Okay.
minute.
Okay.
Ma'am, is it visible now, ma'am?
Yes, sir. Visible, sir.
Ma'am, audible, ma'am?
Yes, sir. Audible. Audible.
Okay.
Okay, sir.
Mr. Arun, your PPT only going. No
Sir, your
audio.
voice is not audible, sir. Arun, sir?
Yeah, ma'am. Yeah, ma'am.
Go back to the first slide. Once again, you just start.
Your voice is too low to hear, sir.
Ma'am, is it audible now, ma'am?
Now audible, sir.
Ma'am, with the full sound.
Okay.
Ma'am, can I present it as next, ma'am? Because the audio in my device has been
Okay, sir. Okay.
disabled, ma'am.
Okay, sir. So next paper ID C002 Aishwarya Kartika Shanbagam. Are you ready, ma'am? Aishwarya, ma'am. C002. So, okay, next paper ID C016 Primalada Ilongo one is here. Primalada, ma'am.
1 second, ma'am.
Okay, ma'am. Okay, ma'am. Share your presentation, ma'am.
Oh, yeah, come 1 second, ma'am, please.
Primalada, ma'am.
Ma'am, is it visible?
No, ma'am. Ma'am, share
Oh,
your
one,
presentation, ma'am.
oh, 1 second,
Okay,
ma'am.
okay, ma'am. Okay.
Ma'am, is it visible?
Yes, ma'am. Is it visible, ma'am?
Oh, okay, ma'am. May I start my presentation?
Okay, ma'am.
Okay. Good morning. Good morning, one and all present here. I am Premalata. I'm a research scholar. I'm going to present a paper on the topic a review on polyurea as a strengthening material for structural concrete elements. What is polyurea first? A polyurea is a elastomer. It is a product of polymerization of blended resin and isocyanate materials. Isocyanate material is a low molecular weight materials. There are two types of polyurea. One is aromatic.
Premalada ma'am, one minute ma'am.
Okay.
Ma'am, kindly change your phone in landscape mode, ma'am. It is in portrait.
Okay, okay.
Okay, ma'am.
Is it okay, ma'am?
Ma'am, it is in portrait, ma'am. Kindly change landscape mode, ma'am.
Okay,
Rotate,
ma'am.
rotate, ma'am. Auto rotate. Raghavan sir.
Is it okay, ma'am? Hello, ma'am.
No, ma'am. Now it's in portrait mode, ma'am.
Oh, still it's in portrait mode. Wait a minute, ma'am.
Ma'am, wait a minute. We will present your presentation, ma'am.
Okay, ma'am. Okay, ma'am. You share my presentation. I'll present, ma'am.
Now you can give stop presenting. We will share your presentation. Already you had
Okay, ma'am.
sent your presentation to our mail ID. We will share your
Yes, ma'am.
presentation. Okay, thank you, ma'am.
Thank you.
Now you can start your presentation, ma'am. We will change slide one by one.
Okay, ma'am. Okay, ma'am. Sure. Thank you,
Okay,
ma'am.
thank you.
Okay. Okay, thank you. Okay. Good morning to another person here. I'm Premalata. I am a research scholar from Jaslam College of Engineering. My presentation title is A Review on Polyurea as a Strengthening Material for Concrete Structural Elements. First, we have to know what is polyurea. A polyurea is a elastomer. It is a product of polymerization of blended resin and isocyanate. Isocyanate is a low molecular weight material. So it can passing through a very minute holes and minute pores also. That's why only we are using in the concrete. There are two types of polyurea. One is aromatic and is aliphatic. These types are based on the type of isocyanates we are preferred. So what is aromatic? What is aliphatic? Aromatic polyurea, its very nature is it is very durable, like that of aliphatic, but it is not light tolerance, that is UV tolerance. Which if you are exposing the aromatic polyurea to the UV rays, that is sunrise, its color is changed. But in aliphatic polyurea, its color is not changed. It is very stable in UV radiation. Otherwise, aromatic and aliphatic polyurea properties are very same. Okay, what is properties of polyurea? It's a very fast setting time. We know epoxy. We are using epoxy for more than decades. But epoxy setting hours is more than 24 hours. But for polyurea, it is only 2 to 5 minutes, even a seconds also. It is very excellent resistance to abrasion and scratch resistant. It is also very stable resistance to weather and environmental condition. Very beneficial elongation up to 400%. It also applied in various temperature conditions. But epoxy is not like that. It's a polyurea we are able to apply in minus 30 degrees Celsius and also up to 93 degrees Celsius also. The coating thickness can be finely controlled by a spray gun because we are applying the polyurea on the concrete by a spray gun. And also very effective bonding because during testing, no failure of debonding occurred in the polyurea coating like that of epoxy. Excellent chemical resistance and a low viscosity, high tensile strength equally 29 to 45 megapascal based on the types we are selecting. And polyurea in construction. Next. Polyurea is widely used in construction as a waterproofing material or sealant or it's a repairing material in bridges. It's also a clean technology compared to other other coatings because it is not toxic. It is not toxic and it didn't produce any pollution. Overall cost is high actually because it's for square feet its cost is 250 to 575. But for epoxy the cost is very less. It is 30 to 150. But compared to epoxy, the lifespan of polyurea is really 25 to 30 years. But for epoxy, we know 3 to 5 years only epoxy. That's why only we are going for the polyurea construction. Polyurea coating in coating for protective coatings in a construction field. But nowadays it is idea of polyurea coating as a protective coating is changed into a strengthening material because it gives more excellent properties in the strengthening techniques. That's why only I am review this paper. Okay, next is structural elements. The polyurea coating is now used in a strengthening material for the structural elements that is beam, slab, column, and other materials also. So first beam, we know beam is the direct element connected to the concrete and also it is support the slab. It transfers the load from the slab to the column. So beam strengthening of beam is very important because we are further suppose in case of any structures we have to increase the load for further or because to repair the deterioration property we need some repairing material or strengthening material. For that some of the authors review about a polyurea as a strengthening materials. Polyurea is in use for 1980 from 1980, but as a strengthening material, some researchers start the polyurea as in 2013 only. So A.E. Morrow in 2015 first studied the shear and flexural behavior of reinforcement concrete beams coated with a spray polyurea. He cast the specimen in small scale and large scale, tested under a 2-point load. The thickness of the spray coating there adapted is 2 mm, 4 mm, and 6 mm. They concluded that compared to flexural behavior, this polyurea coating enhances the shear behavior of the coating, increasing the thickness of the coating, increasing the strength and ductability. The properties of a polyurea, we know that a tensile strength is very high. So it actually increases the flexural strength and also a shear strength. Courtney E. Green at 2013 also studied the flexural strength, shear strength by spraying polyurea along discrete fibers. They are using the discrete fibers of 6 mm length and they spray polyurea and fibers simultaneously on the concrete. It bonded very well with the concrete. They concluded that the coating thicknesses is 4 mm. It increases the flexural strength up to 50% compared to the conventional concrete. And also they provided that the tensile strength based on the fiber volume also included. So JASAC at 2013 used a polyurea coating as a low longitudinal reinforcement ratio, the RCC beam, because due to the tensile strength of the polyurea coating, they used as it's a reinforcement material also. The thickness of the coating ranges from 2.5 to 3 mm. The polyurea coated beam has no cracks or debonding until the complete breakage of beams under bending. The loading or unloading are safe in the polyurea coated RCC beams compared to the conventional RCC beams. Next, the topic is slab. We know what is slab. Slab is the main live load carrying material. It transfer the load from the slab to the beams and the beam to the column to the foundation. So slab. So mainly the slab topic is based on the blast mitigation. The main topic which encourage the civil engineers to use polyurea as a strengthening material is the blast mitigation effect of the polyurea coating. So Corbin et al. At 2022 studied the strengthening effects of polyurea on ultra-high performance concrete slabs. They explained that the blast mitigation effect is very high based on the thickness of the coating. They opt the thickness of 8 mm to 12 mm. The polyurea coated UHPC, that is ultra high performance concrete, shows good anti-blasting characters when the scale distance is decreased. Muhammad et al. 2012 studied the flexural properties such as yield load stiffness and energy dissipation and lightly reinforced slab are increased. The thickness of the polyurethane thin spray liner also influences the flexural property of the concrete slab. And each in 2019, ma'am, please change the slide. Next, last, next, next. Yes, each and no, previous slide. Yes. Ocean 2019 studied foam concrete. They're using the polyurea coating as for the production of foam concrete. They concluded that the polyurea coated at the bottom AEC panel does its debonding after explosion testing. So it is mainly used for the blast mitigation effect. They concluded that it is more attractive towards the civil engineers. The structural damage factor for the polyurea coated panel is very less compared to the CFRP coated panel. The blast resistance of polyurea coated concrete is very high during explosion due to the ductile property of the concrete. Next is column. We know the basic concept, strong column, weak beam theory, because if a column fail, the whole structure will fail. If your beam fail, that a structure that a particular floor will fail. So we have to prevent the strengthen the column. So next is column. Bingayo at 2022 studied the properties of ultra high performance concrete column. They conduct the test of drop weight impact. Suitable, they decide the thickness to 2 to 6 mm to resist impact loading. Shear failure is less in case of the polyurea coated compared to the non-conventional UBHSC. Thus, enhances the lateral impact resistance capacity of the column. That's why only now engineers decide to study the seismic effect of polyurea coated concretes. So next is T. Healy et al. At 2022 use the stiff type polyurea. That is, the thickness is it is very stiff. Actually, elongation is very less, but tensile strength is very high. This is stiff type polyurea property. They used as a seismic retrofitting material for a column. They casting the rectangular column, circular column coated with polyurea, and also they use the glass fiber reinforcement polyurea sheet to withstand both static and dynamic load conditions. But this author concluded that the GFRP shows debonding at the corner of the rectangular column. They consider the thickness of 5 mm. So under seismic loading, polyurea is a good strengthening material. Jun Huk Song at 2022. Polyurea is a bonding material between GFR and concrete. He uses a polyurea as a resin material. We using always epoxy resin between concrete and the GFR sheets. But he uses the polyurea as a resin between GFR and concrete. In the type, we have to going for the aromatic polyurea because it is the matte type. It's not a glossy type aromatic. So for as a resin, we have to go for the aromatic. They use the aromatic. The shear strength of GFRP column is very high. They concluded that the GFRP column is very high compared to the plain polyurea coated column. Also, they told the 9% result is higher than the conventional. Next topic is miscellaneous other related topic in a concrete. Ozaki et al. At 2020. Ma'am, next slide, please. Next. Ozaki et al. At 2020. They used a resin for FRP sheet wrapping. So some authors concluded that it is a good resin for FRP sheet and a concrete. Some authors concluded that there is a debonding occur during the loading. So it is not concluded, it's not yet decided it's a good bond material or not. So studies are going on. Now only they are starting about the research on polyurea as a strengthening material. So some controversies are going on in that bonding. Also, polyurea increases the delaminating load FRP wrapped concrete due to its internal fracture energy. Next, JASEC 2020 examined the polyurea coating as a ring material. It's for ring materials. He provided testing the crushing strength. In the crushing strength test also, he concluded that it increases the crushing strength. So finally, my conclusion is it increases the flexural strength, and also a shear strength up to 50%. With fibers and without fibers also it increases the strength. And also it acts as a reinforcement material. It also enhances a tension failure other than the shear failure. The thickness of the polyurea coating is yet not decided because it is research is going on. They are varying from 2 to 12 mm based on the test. The different authors proposed a different thickness of the coating, so it is yet not decided. And also some authors provide it is a good resin for external strengthening material of fiber reinforced sheets or plates. But some author decides that it is not a that is debonding occurred during the testing. So it is also not concluded because research is going on based on that. The polyurea coating on concrete mitigates the blast mitigation effect is very high, but it is very purely it is a theoretically and practically it is proved. It is a very good blast mitigation effect. Polyurea coating resists seismic force by acting as a reinforcement. But still, polyurea coating has to be studied in the field of strengthening concrete to decide the optimal thickness and also other characteristics, and also used along with the other concrete like self-compacting concrete and RCs, ready-mix concrete, and some geopolymer concrete. So in some fields, we have to going for the polyurea coating as a strengthening material. So research is going on that. But my interest is in polyurea because I am doing research in the polyurea as a coating material for reinforcement and a self-compacting concrete. So I am also doing the comparative study. So this is my final conclusion. Thank you for giving the opportunity. Thank you, everyone.
Miss Premalata?
Sir, sir. I'm very glad to talk to you again, sir.
Is it a review paper or your research paper?
Review paper, sir. Review paper, sir.
May I know that what do you understand about polymerization?
So polymerization is the combination of resin and a hardener. It's a two product. It's a
how do you define polymerization?
Polymerization. It's a resin which is reacted to the hardener to form a polymers. It's a nitrogen components with like that.
As you told that the polyurea is environmental friendly.
Yes, sir.
The polyurea itself is artificial synthetic polymer chemicals.
Yes, sir.
Will it not change the properties of soil?
No, sir. No, sir. It doesn't affect that much, sir. Actually, that's the main thing, sir. We have to during applying, we have to provide some protective coatings, but due to the early setting, it doesn't affect with the humidity. It doesn't affect with the soil also because it is set in within 2 seconds to 3 seconds. For a higher temperature region, we also extend the time, sir. So it doesn't react with some humidity, some years, or it's on your soil, sir.
Is it confirmed? Because some of the material in working temperature, they may behave normally, but in high temperature, they start to disintegrate. Sometimes some fumes or some unwanted adverse material will be released. Is it confirmed in your literature survey?
Yes, sir, yes, sir. It is. It is in the based on the. It's a polymer. It's this polyurea is widely used in many areas, sir. Based on from 1980, they are concluded that they are very sure about it. It withstand from -30 degree to 93 degrees Celsius without any reaction, sir.
One more question. The polyurea coating itself will enhance the ductility property or flexural, or
yes, sir. Yes, sir.
fiber to be added.
So first, they are adding with the discrete fibers. They are also investigate with the fiber sheet also. But nowadays, they are concluded that polyurea itself increases the tensile strength, sir.
Somewhere you have mentioned that drop weight impact resistance. What code you refer? Whether that previous researcher is referred, which code based on that the drop weight impact resistance was measured?
Oh, sorry, sir. I didn't know. I didn't notice that which
you
code they followed.
And you should know, na, that is
Yes, sir, because I'm not taking that column property for my research, so that is one day I just basically I just take the concept in columns, sir. Sorry, sir. I will surely know about that in future, sir. Sure.
Are you a research scholar or you're a PG UG or PG
So
student?
I am a research scholar. I am also your ME student, sir.
Then you have to concentrate on that. Please refer
Sure.
ACI 9544.22R.
Okay, sir. Okay, so for
ACI
drawback impact.
ACI 544.2R. That is the
Okay, sir.
code. That is code is specifically used for drop weight
Drop impact.
impact. Yes.
Okay, sir. Sure, sir. Sure, sure. I will read, sir. Thank you for your
Okay.
valuable knowledge, sir.
Okay. Okay. All the best.
Thank you, sir. Thank you, sir.
Thank you, Premalada ma'am.
Thank you, ma'am.
Thank you, sir. Now I call upon Jnana Sundar sir to present your presentation. The paper ID CE 024. The authors are Jnana Sundar, Vinodini, and Naga Viswanath. Jnana Sundar sir.
So next paper ID CE001. Arun Siddha, sir.
Yeah, ma'am.
Okay, sir. Wait, sir. Yes, sir.
Ma'am, whether you will present or shall I present?
Arun Siddha sir, your presentation need access.
Okay, ma'am. Then I will present it, ma'am.
Okay, sir.
I'm my screen.
Yeah, visible, sir. Thank
And my
you.
presentation, ma'am.
Yeah, sir, visible. You can start, sir.
Okay.
Okay, sir.
A pleasant message to everyone. I am Arun Siddharth from Banana Institute of Technology, here to present a PPT on a topic experimental investigation of self-compacting concrete using waste materials. Here we talk about the waste materials such as fly ash and granite waste for replacing fine aggregates. The main objective of the study is to provide a greener environment to find the fresh and harder properties of the self-compacting concrete and to replace the fine aggregate with waste materials to avoid depletion of fine aggregate present in the natural resource. Why we need self-compacting concrete? Self-compacting concrete, it is a special kind of concrete, and it needs no compaction, and a very less compaction is being needed. It can be used in high-rise buildings, high flow consistency, and can be used where the reinforcements are very densely packed. The materials used in this type of concrete are cement, coarse aggregate, fine aggregate at a very low rate, and for replacing the fine aggregate, we used granite waste powder, microsilica, and for admixture we have used superplastic. The methodology where we processed for making self-compacting concretes are we done a survey on the literature, and we came to know about what is self-compacting concrete and how the mixes are being made it for it, the binder materials used in self-compacting concrete, and the mix design that has been drafted using IS 10262 2019, and the properties such as phase properties and mechanical properties are being analyzed, and later the results has been noted. The mixed proportion of self-compacting concrete has been listed in the table, and the amount of and the volume of replacement is also been clearly subjected in this table. The different types of tests provided performed for for finding the present hardened properties of the concrete, sir. Workability tests such as slump flow, V-funnel test, and L-box test has been conducted. For finding the hardened properties, compression test has been performed, and for analyzing the durability test, sorptivity test, and water absorption test has been performed. Slump flow test. The flow test is a method to determine consistency of flush concrete. The maximum flowability value of the self-compacting concrete is obtained as 720 mm. Wave funnel test. Determine the filling ability, flowability of the concrete with the maximum aggregate size of 20 mm. The feed funnel test is obtained as 10 seconds. The L-box test is used in laboratories to access the strength of concrete. The L-box value is obtained as 0.93 for this self-compacting concrete. Water absorption test. To determine the moisture content of concrete specimen, the optimum value of water absorption is observed as 2.5 to 4% of water absorbed. And this table represents the superplasticity dosage and the slump flow, V funnel, J ring, and L box based on for the different kinds of mixed designs. This table represents the water absorption test for different kinds of concrete mixes. Compression test. The compression test were performed for the cubical specimen 150, 150 into 150 mm after 28 days, and the optimum value for the compressive strength is found as 59 kilonewton per mm square. The compressive strength of concrete at 7 days and 28 days are been represented as the image. At the 7 days duration, the replacement of fine aggregate with 20% of granite waste and 0% of fly ash given the maximum strength of 42 kilonewtons in 42 megapascal in the day in the seventh day, and the same mix after 28 days it been results in the 52 kilonewton 52 megapascal at the result at the end of 28 days. And the flexural strength of concrete is also been observed as the maximum for the same kind of for the same mixed ratio of with 20% of granite waste and 0% of fly ash. The conclusion: the replacement of granite waste for concrete above 40% affected the fresh properties of concrete drastically. Replacement of fly ash to some percentage of cement was found to minimize the effect of fresh properties to some level lower than the concrete when granite waste are waste. The mechanical properties of concrete such as compressive and flexural strength are found to increase when the granite waste is used in self-compacting concrete up to 40%. The use of granite waste up to 60% in self-compacting concrete reduced the water absorption. Finally, the combination of granite waste 60% and fly ash 30% were found to give the better results when compared to other mixes. Thank you.
Mr. Arun,
Yes, sir.
for self-compacting concrete, what is the maximum size of aggregate is recommended?
Sir, it's based on the reinforcement.
Okay, of course, there is no manual manipulation or intervention will be there. The concrete automatically starts set. For that, the literature says that the maximum size of aggregate should be limited to somewhat. But
Yes,
we
sir.
have used 20 mm size. It is possible you will get 100% result in SSC.
Sir, we used the 20 mm and we have.
Please refer that the SSC. If you want effective result, you have to control the size of the aggregate around 10 or less than that. Please check that.
Okay,
That one more thing, the granite dust you have replaced is replaced for which one?
sir, for fine aggregate, sir.
Fine aggregate.
Yes, sir. So we
Have
used
you?
to fine aggregate in a low volume and for if we use 50% of fine aggregate means we have replaced it with 20%
Can
with
you
granite waste.
can you present that mean display your PPT?
Sir, sure.
Please.
Go to the conclusion.
Okay, sir.
Here you are seeing that replacement of granite waste in concrete about 40% affected fresh concrete. So
Yes,
granite waste you have replaced the fine aggregate, right?
yes, sir.
Have you checked that compatibility between granite waste and fine aggregate? Yeah, is it your research? You are working in the research or is a review paper?
Sir, no, sir. It's a kind of review paper, and
Hmm.
it's a kind of review paper.
Then the next point you showed that replacement of FA. What is that FA? Is a fly
Sir,
ash or fine
flyers,
aggregate?
flyers, flyers.
To minimize the effect of what type of fly ash you are used here?
Sir, flyers of
Because there are some types, 2 3 types of fly ash is there.
yes, sir.
Every fly ash is having a different nature and properties.
Yes, sir.
Here, which fly ash you have replaced the cement? Okay. Next one is you have shown that the mechanical properties of concrete such as okay use of
Hello, sir.
40% and finally combination of ground what is that 60% granite waste and fine fly as a 30%. These both are directly getting related or
So, yes, sir. While we used the mixation, we replaced the fine aggregate with 60% of granite waste and 30% of fly ash in the same concrete mix.
that mean fly ash is replacing cement and granite waste is replacing fine aggregate, right?
Yes, 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 yes.
Uh, then the superplacer, what type of superplacer we have used here?
Sir, to increase the flowability content, sir.
Now, what type? Because there are n number of superplacer types are there.
Yes.
And somewhere you are told that already fine aggregate you are using and microsilica also you are using. And you have used that IS 10262 2019 mixing code. It is
Yes.
applicable for self-combining concrete also.
Sir, this is research
Suppose
paper.
suppose you are casting a system for durability. What is the minimum period you have to keep under watch that for durability? Do you
Sir,
understand that what I am
yes, sir,
asking
yes, sir,
you?
yes, sir, yes, sir, yes, sir, I can understand.
For durability test, what is the minimum period to be under observation?
Sir, 24 hours.
24 hours.
Yes, sir, for water absorption, kept
Is that
24.
correct? You are ME student or UG student?
Sir, UG student, sir.
Uh, you please check with your supervisor, otherwise your guide.
Sure, sure.
For durability, minimum 90 days is required,
Okay, sir.
right? It's a
Okay, sir.
long-term property.
Okay, sir.
Okay.
Okay, sir.
So all the best. Actually, madam, if any question you can ask actually.
Okay, sir. Okay, sir.
Mr. Arun,
Yes, sir.
how much water reduction is possible in self-compacting concrete?
Sir, actually, this paper has been made by our faculty, sir, and I just will presenting it. So I have no idea, and haven't talked to them.
Can you consult with your guide? Okay.
Sure,
You try to refer the water reduction
sure,
amount.
sure, sure, sure.
Thank you, Arun sir, Ravi sir. So next paper ID CE 032. Dhanlakshmi ma'am.
Yes, ma'am.
Share your presentation, ma'am.
Okay, ma'am. Thank you. Okay, ma'am. Shall I start the presentation, ma'am?
Okay, ma'am. Okay, ma'am.
Okay, ma'am. Myself, Dhanlakshmi. This is scholar in PSR Engineering College, and my topic is an experimental study on concrete with partial replacement of cement by rices ash and bagasse ash. Introduction. Concrete is the most common building material made by man. It is obtained by mixing the compositions of cement, water, aggregate, and additives with the required proportion. Normally, nowadays, the concrete production cement is the major
Ma'am,
part. Ma'am,
ma'am, put
Please
it in
change
slides.
the
So,
slideshow.
already shared, sir. Not.
You change to slideshow.
Yes, sir. I'm sharing in slide share only, sir.
ஸ்லைட் ஷேர் பண்ணிருக்கீங்க மேடம். ஆனா வந்து
ma'am,
ஸ்லைட்
Yes.
ஷோனா அந்த அந்த இது மட்டும் தான் தெரியும்.
you
லெஃப்ட்
just
சைடுல இருக்கிறதெல்லாம் தெரியாது.
Press F5 button.
கீழ பாருங்க ஒரு ஸ்லைட் ஷோ மாதிரி ஒரு ஆப்ஷன் ஒன்னு இருக்கும்.
இல்ல சார், ஆல்ரெடி ஸ்லைட் ஷேர்ல தான் போட்டிருக்கேன் சார். நெட் ஓகே சார். ஒன்ஸ் அகைன் ஐ வில் சேஞ்ச் இட் சார்.
ஸ்லைட் ஷோனா உங்களுடைய இந்த ஸ்லைடு மட்டும் தான் தெரியும். ஆக்சுவலா அந்த ஃபுல் இது ஸ்கிரீன் வரும் அது. ஓகே, கண்டினியூ.
Okay, sir. Whether it is visible, sir?
Ma'am, press F5, ma'am.
Ma'am, already shared, ma'am. Screen shareல தான் இருக்குது, ma'am.
Okay, ma'am. You can present.
Okay, ma'am. Thank you, ma'am. The strength and durability and other properties of the concrete depends on the concrete components such as mixing ratio, compaction method, and other controls during the setting and hardening property of the concrete. With the remarkable development of the concrete industry, the recycling materials of the waste materials is using in the construction industry is widespread nowadays. So some of the composite materials which are comes under the category of agro waste materials are used in this investigation. The cement replacement materials such as fly ash, silica fume, rice ash, sugarcane ash, and slag fiber, gravel material, and marble and granite powder dust materials were used as a partial replacement for cement nowadays. Rice ash and sugarcane ash can be the potential substitutes for other natural wastes, such as the rice husk and bagasse ash have the more amorphous silica in the physical properties as well as in the chemical properties. So the strength of the concrete will be improved.
ma'am, hello.
Ma'am,
Dhanlakshmi, ma'am.
sir, sir.
Kindly change your window in full screen mode, ma'am.
இல்ல சார், இங்க ஷேர்ல தான் இருக்கு சார். அதான் ஃபுல் ஸ்கிரீன்ல தான் வச்சிருக்கேன் சார். மேம், ஃபுல் ஸ்கிரீன்ல தான் வச்சிருக்கேன் மேம். Sir, whether it is visible, sir? Hello, ma'am.
Ma'am, ஒரு slide is visible, but not.
இல்ல சார், ஃபுல் ஸ்கிரீன்ல தான் வச்சிருக்கேன் சார். அதான் ஸ்லைட் ஷேர்ல தான் ஓபன் பண்ணிருக்கேன் சார்.
தனலட்சுமி மேடம், கீழே பாருங்களேன், நோட்ஸ் அந்த வரிசையா பார்க்கும்போது ஒரு ஸ்லைட் ஷோ மாதிரி ஒரு 1 2 3 4 5 6வது பாருங்களேன், அதை கிளிக் பண்ணுங்க. இந்த ரைட் கார்னர் பாட்டத்தில் பார்த்தீங்கன்னா அந்த வால்யூம்க்கு பக்கத்தில் ஒன்று தெரியுது பாருங்க, வால்யூம் ஜஸ்ட் பிஃபோர் தட். அதை கிளிக் பண்ணீங்கன்னா உங்களுக்கு வந்து ஃபுல் அது ஸ்லைட் ஷோ காமிக்கும். ஆர் யூ லிசனிங் மீ?
Dhanalakshmi ma'am, my voice is audible for you.
Yes, sir.
Plus F5. F5 click பண்ணுங்க.
சார் இல்ல பண்ணிட்டேன் சார். எனக்கு வந்து ஃபுல் ஸ்கிரீன் தான் வருது சார்.
மேம் நோ ப்ராப்ளம்
மேம் நீங்க
மேம். ஸ்டாப் ப்ரெசென்டிங் கொடுங்க மேம், நம்ம இங்கேருந்து ப்ரெசென்ட் பண்ணுறோம்.
ஓகே மேம், ஓகே மேம்.
ஓகே மேம், ஓகே மேம்.
Ma'am, ma'am.
Okay, ma'am.
Now you start.
Ma'am.
Start.
Okay, sir. Thank you, sir. Thank you, sir. My topic is an experimental study on concrete with partial replacement of cement by rice ash and bagasse ash. Okay, introduction. Concrete is the most common building material made by man. Nowadays, the concrete, during the production of the cement, there are so much of carbon dioxide is emitted and pollute the environmental. So it affects the it increases the greenhouse and global warming effect. Due to the fact reduction of the cement production, we are using the partial replacement of cement materials such as fly ash, silica fume, rice ash, sugarcane ash, and slag material, and granite and marble powder, dust material, etc. In this investigation, rice ash and sugarcane ash was used as a partial replacement of cement with some combination of the proportion. The proportion is made with the 5% increment of the 5% and up to 30%. The combination of both rice and bagasse ash were used. Why we chosen the rice and bagasse ash means in chemical properties it has the highest silica content in its composition. So we are using that materials as a partial replacement of cement. Next, by the addition of the rice and bagasse ash, it increases the workability and reduces the impermeability and the resistance of the steel reinforcement. Also, using the rice ash in the cement content, concrete making producing is efficient, and in an environmental factor it gives a lot of benefits to the society. It reduces the CO2 emissions by replacing the cement with agricultural waste. Why we chosen the agricultural waste means it is wastely dumped on the environment and pollute the environment rapidly, because no one is scared. So utilizing that waste in the concrete gives the green concrete to the society. So in this work, the strength and the durability properties of the concrete were determined with the different percentages of replacing the cement with a mixture of rice husk and bagasse ash in different proportions from 5 to 30%. Next. So this is our methodology. First, literature collections, materials properties, find in the physical and chemical properties, and mixed design. The mixed design were arrived from with the help of IS 10262 2019, and then experimental study. In that experimental study, both the strength and durability properties were studied. In strength property, compressive strength, split tensile, and fractural strength were determined, and in durability, acid attack and sulfate attack. Then resultant discussion and conclusion. Material used in this investigations, cement OPC 43 grade was used, and risers and bahashas was collected from the nearby industry, and both ashes were collected from the yard and maintain 750 degrees Celsius for the burning, and then after the 750 degrees Celsius we collected ash directly from the local buyer. Then fine aggregate, here the normal river sand is used as a fine aggregate, and coarse aggregate 20 size of the coarse aggregate was used, and the super plasticizer in this Conplast SP340 was used because it chloride free content, it is comes under the category of sulfonate and naphthalene based polymer. So in the, it is used in the concrete means gives the higher workability and improves the property of the concrete. This is the mixed proportion. The fine aggregate and coarse aggregate is common for all the mix. Replacing the rice husk ash and bagasse ash were made with the additional increment of 5%, 0 to 30% were made. In this 70% was constant, and the remaining 30% was splitted. Experimental investigation. In this research, result based on the experimental was carried out. The compressive strength of the cube, tensile strength of the cylinder, and fractural strength of the concrete prism were determined. For the compressive strength, 100 by 100 by 100 mold size was used, and the cylinder 75 dia and height 150 were used. The size of the prism is 500 by 10 by 10 The behavior of the concrete with various types of proportion is studied through an experimental program. In this, the grade of concrete M30 was chosen, and the water cement ratio is fixed as 0.55. The strength properties were evaluated with the help of the compression strength, split tensile, and flexural strength, and durability. Both acid attack and sulfate attack and UPV and rebound hammer test were conducted and evaluated the test and find out the optimum mix for the suitable concrete. The percentage of the partial replacement of cement with rices ash and bagasse ash is increased in the order of 5%, and all the cast specimens were taken at the test at the age of 7, 14, and 28 days of curing. Then the compressive strength result, the compressive strength was tested at the age of 7, 14, and 28. In this, the M4 gives the optimum mix. It gives the higher strength on comparing with the conventional and other type of concrete. The M4 denotes next. M4 denotes the 70% of cement and 20% of rice husk and 10% of bagasse ash. The percentage of the additional increment for the replacement of cement with the rice husk ash is increased in order of 5. Why we chosen for 5 means the reduction factor get increased, and the chemical properties were changed even that 0.1% also. So 5% was chosen to denote the good reactivity when used as the partial replacement for the silicates material. Next. This is the result of the split tensile strength. Split tensile strength were determined for 7 days, 14 days, and 28 days. In this, the 6.1 megapascal is the highest strength. It also gives the higher strength in comparing with the M4 gives the highest strength on comparing with the other mix. The result from the graph, the result shows that the compressive strength is optimum at 70% of cement and 30% of the replacement material, such as 20% of rice husk and 5% of bagasse ash. In this, the bagasse ash has the low water absorption capacity as compared with the rice husk ash, and it low loss of ignition. So the particles of the bagasse ash has irregular and rough texture. Due to this, there is the bonding between the concrete is very easy. So hence it is a cost effective and environment friendly construction used for the sustainable use of the concrete. Flexural strength of prism. In this also, the 28 days of flexural strength attained is 4.52 megapascal. It is the highest on comparing with the other mix. In this flexural strength, the retaining capacity of the Bahas ash and the Rice's ash is vary depends upon the mixing property of the concrete. It produces the efficient concrete with optimum mix percentage, because the Bahas ash and the Rice's ash having the low specific gravity as compared to the cement, because it having the high volume of the content. During mixing, it randomly affect the mixing property and flexural property of the concrete. Next, from the result on flexural strength, also M4 gives the higher flexural strength, which contains 70% of the cement, 20% of Rice's ash, and 10% of Bahas ash. The result observed that the combination of the both Rice's and Bahas ash significantly increases the strength of the concrete. Acid attack. In acid attack, sulfuric acid was used. 5% of the sulfuric acid was used for the total volume of the content for used for the curing. In this also, M4 gives the optimum result. It shows the reduction in compressive strength is low for the M4 proportion. Sulfate attack. In sulfate attack, we are using the magnesium sulfate. The same 5% of the magnesium sulfate was immersed in the water. It shows the same proportion gives the higher result. On comparing with the acid attack and sulfate attack, there is no greater changes up to M30% of Rice's ash. But in after 5% of the Bahas ash, it reduces the magnesium sulfate content, got lot of deterioration in the concrete. Next one, ultrasonic pulse velocity test. This is the ultrasonic pulse velocity test. In this test, all the materials are good in conditions, because the average velocity is maximum above 4, and the properties of the after acid attack also it shows the good property. So the concrete is good concrete, and it can be applicable for the construction industry also. Rebound hammer test. Rebound hammer test, the same M4 shows the maximum value, maximum compressive strength is 37 megapascal. And before acid attack and after acid attack, there is no gradual increase in the deterioration. So it is the combination of the Rice's and Bahas ash in the concrete is benefited. From the result of the ultrasonic and rebound hammer, the same 30% of the replacement, that is 20% of Rice's and 10% of Bahas ash, higher compressive strength of the 37 megapascal and 38 megapascal for the after acid attack. And compared to the conventional concrete, it is nearly 20% of increment in the compressive strength. Conclusion. The usage of the Rice's and Bahas ash can be used as a cement replacement material, and it gives opportunity to the construction industries to reduce their cost and thereby preserving the environment quality. Because of the replacement of the cement material, randomly we reduces the environmental pollution. It is the ultimate aim. And the concrete with the replaced material with these agro-based residual wastes shows the comparable strength as compared to the conventional cement concrete. From the experimental work, it was found that the combination of 20, comparing with all testers, the maximum optimum value attained is 20% of Rice's and 10% of Bahas ash as a replacement of 30% cement, with 70% of cement utilization for both the strength and durability properties. The test result of compressive split, flexural and acid attack were indicated that the strength of the concrete increases with respect to the percentage of ashes present in the concrete. Thank you, sir.
Dhanalakshmi,
Sir,
you are a ME student or UG student or a research scholar?
research scholar, sir, but it is my review paper, sir.
I would like to ask some questions.
Okay, sir.
You use that Rice's gas and Bacchus.
Yes, sir.
Why you have chosen both? Both are basically same nature.
Yes, sir.
What
Both
the
are,
difference you found that you are combination having the combination of both?
sir, as compared with the rice cash, Bahasas have low loss of ignition, sir. So the heat of hydration process is reduced during the missing property, sir. As compared with the rice cash, why we chosen these two combinations means both the materials having nearly the same material properties. But ultimate aim is the agro-based residual waste were utilized in our project, sir.
Okay, you have mentioned somewhere that amorphous silica.
Yes, sir.
What do you understand about amorphous?
Sir, during the XRF testing, it gives the result as amorphous.
Just I am asking that. What do you understand about amorphous?
Okay, sir. It is powder in nature, sir. After durability after 28 days only, it start its reaction, sir.
Why I am asking that your research scholar amorphous mean something different, and particularly when you want to get amorphous silica, you have to incinerate the material to some very high temperature. You are used only 750 degrees centigrade.
Yes, sir. The ash was collect
Because
was
in a
nice
750 degree centigrade, the ash is not sufficiently burnt. And
Okay,
when you
sir.
are using this material in a concrete, you will not get the bonding also properly. If you want that, I say that it will be a benefit for you only.
Okay,
Amorphous
sir.
mean
Okay, sir.
is having no shape at all. That what I meant to say there is shapeless.
Yes,
We
sir.
cannot define to some particular shape. When
Yes,
it
sir. Yes,
will
sir.
be getting that you have to incinerate in 1,000 degree and above. Then
Okay,
only
sir.
this type of ash can be used in concrete. Otherwise, you will not get bond at all.
Okay, sir. Okay,
Right?
sir.
Then
Okay, sir.
suppose you are adding around 30% ash in a concrete, whether your initial setting time and final setting time will change or not?
Change, sir.
Change. Whether
Because I, sir,
it will increase or it will reduce.
no, sir, increase after 30 percentage. There is takes some
Just
time for
when
setting,
you are
sir.
adding
Okay.
ash in when you are replacing OPC cement,
Okay,
whether
sir.
this IST FST will increase or not?
Increase, sir.
Increase.
Yes, sir.
That means that you will not get yearly strength.
Yes, sir. So it takes some time to curing, yes, sir. Because up to
Hey,
30 percentage means
whatever the
the
question
next
I am
day we
asking, you
demold.
take it in a positive side because you are doing a
Okay, okay.
research,
Yes,
right?
sir.
And
Okay,
one
sir.
more
Sure,
thing
sir.
I will tell that the Facelonas generally is supposed to have a silica and alumina both together. But these materials are 100% siliceous material. Only
Yes,
silica
sir.
will be here,
Yes, sir.
right? Okay,
Yes, sir. Yes, sir.
when we are adding this type of ash, we should be very much careful. And one more
Okay.
thing, this all getting from live organism. So if you find that micro shape, it will be cellulose type. So you have to see that compatibility also. It will not set
Okay,
with
sir.
other material. Okay. So the acid and the sulfate attack test you have done. What is the minimum period you have carried out? What is the minimum period required for this durability test?
Sir, we tested after
How
for
long you
28
have
days.
kept your specimen in
Sir,
this solution?
no, sir. After 28 days of curing, solution is 14 days.
Only 14 days.
Yes, sir. Yes, sir.
No. It's not at all enough. It's at least that it should be immersed in minimum 90 days.
90
The
days. Yes,
maximum
sir.
maybe years together, 10 years, 15 years, something like that. Otherwise,
Okay.
90 days you have to immerse because you are doing research. Please take care of that.
Yes. Okay, sir. Okay, sir. Sure, sir.
Yeah, that specimens also, whether you have used Indian code or ASTM code.
No, sir. Indian code only, sir.
Indian code mean cube size is instead of 150 by 150, you use 100 by 100. But in IS code, it is not mentioned that we can use a 100 size
150.
cube. And one more thing, that the cylinder also, IS code say recommends that 150 by
300 by
300.
150,
But
sir.
you have used 75 by 150.
150.
And this prism also, of course, the prism is obeying that Indian code 100 by 100 by 500. Okay, this all you have to see that. Suppose, okay, then the split tensile and modulus or rupture test, that is flexural strength. What the code says that what is the range we supposed to get? Can you are understanding my question?
3
Can you
to
correlate with this split tensile and modulus or rupture to cube strength?
sir, 1 by 20 of its compressive strength.
Yeah, what I am asking, suppose 40 Newton per mm squared you got on a cube strength. Suppose
Okay,
this,
sir.
if you are having a cylinder, if you are
Okay.
checking that split tensile, how much strength supposed to be? Because roughly there are some percentage is there. Otherwise, in IS code, IS 456 page number 5,
Yes,
there
sir.
is
If
a one
the concrete, yes, sir,
one
depends upon the
formula.
grade of the concrete.
The
5,000
formula
root
also is
FCK.
there. Formula is there.
Yes, sir. 5,000 root FCK, sir.
So what is the specific gravity of Rice's gas and August? Because you told that
Nearly 2. It's nearly 2.9 and 2.8. Yes, sir.
but it's almost is equal to cement only.
Yes, sir.
Because
3.1. Yes, sir.
but you told that is very low. Of course, it's very low only because the fly ash is having 2.3, 2.7, something like that. This
Yes,
is
sir.
it should have less than that. And you have taken that value of NDT test. NDT test can we take as a reliable result compare with destructive test results?
Yes, sir.
But one
Both point.
idea
Yes,
is
sir.
there whenever you are using NDT test, you supposed to
Okay,
use
sir.
minimum two equipment, two different instruments to come to conclusion. Otherwise,
Okay, sir.
this is all is for assessing only, not for giving conclusion of your result. Always we should go for destructive test result only.
Okay, sir. Okay, sir.
Okay, this all my
Okay,
questions.
sir.
You take this in a positive side because you
Yes,
are
sir. Yes, sir. I will improve in my research, sir, using
okay.
your points.
Okay, all the best.
Okay, sir. Okay, sir. Thank you, sir.
Thank you, ma'am. Thank you, Ravi, sir. So next paper ID C032. Oh, sorry. Next paper ID C035.
Can I present my?
Yes, ma'am. Yes, ma'am.
Ma'am, is it visible, ma'am?
Yes, ma'am. Is it visible? Ma'am, press F5, ma'am.
Now is it?
Okay,
Is
ma'am.
in full screen only, ma'am?
It is in full screen, ma'am.
Ma'am, I'm Khyati. I'm Khyati from RMK Engineering College, ma'am. I'm here to present about utilization of demolition waste and recycled material in building construction. Definition of construction and demolition waste. It means compressing of building materials or the waste when we will get when remodeling, repairing, and demolition of any civil structure. The materials we get from the construction and demolition waste consists of concrete, brick, timber, glass, steel. The concrete waste, we can use the 30% of concrete waste. We can make it as aggregate, means we can crush it and sleeve it, and we can make it as recycled aggregate. This aggregate we can use in the concrete to make it stronger. This can be used in any road construction or any building construction. Brick. Reusing of bricks is a feasible and sustainable and fashionable way of buildings. The bricks, we need to soak the bricks and we'll get the old mortar. Then we can recycle it and we can make the new bricks. From and demolition activities typically delivered to wood waste recycling operations for processing. This wood waste we can use for flooring. Glass can be repeatedly recycled without losing its quality or strength. In any demolition, glass represents less than percentage. We can recycle it. We can recycle it. Use it for windows. The waste we can see.
Is the slides are visible? For me, it was gone. There is some network issue, I think so. Am I audible to you?
Yes, sir.
But the
Your voice
screen
is.
காமிக்கலையே madam.
எனக்கும் காட்டல சார். ஹைதி மேம், your screen is not visible, ma'am. ஹைதி மேம். ஹைதி மேம். Ma'am, your voice is not audible, ma'am.
Now I call upon Mr. V. Vineet to present their presentation. Paper
Yes,
ID
sir.
CE040.
For Kathy, she will come in 2 minutes, sir.
Sir, shall I start, sir?
You can start, Vineet.
Yes, sir. Yes, sir. Good afternoon to one and all present here. Here I am to start with my topic of experimental study on mechanical properties of textile reinforced concrete. So contents of the presentation is introduction, literature review, methodology, experimental work, results and discussion, conclusion and reference. So in this introduction study, we have to the TRC textile reinforced concrete is the innovative technology concrete field in which the steel reinforcement replaced by textile reinforcement. These are like in fiber mesh and made up of various materials, glass, polypropylene, jute, carbon, etc. Here we have to choose the alkali resistant glass fiber. It is derived from organic non-metallic raw materials. In addition to implementation of the textile reinforcement can improve the various testers using compressive strength, flexural strength and impact strength of concrete. And in order to reduce the concrete weight by using textile reinforced material. And next you have to go in the material study. In the material study, this glass fiber meshes will also in alkali resistance made from non-metallic organic raw ingredients. So alkali glass fiber meshes will also have optimal quantity of zinc-chromium for usage in concrete. This zinc-chromium concentration will be used to prevent the alkaline corrosion. So overview of the project is, in order to study the material properties of the cement, sand, and coarse areate of the various materials, and we have to casting of the specimen of prisms, the different layers, and using alkali resistance glass fiber mesh. And the cast specimens will also use it to test the mechanical properties, compression strength, impact strength, and flexural strength. So literature review. So literature review, cracking behavior of textile reinforced concrete with varying concrete cover with and textile reinforced finish. So TRC construction also used to layer more elegant and more efficient than RC structures. In order to increase the matrix strength, requires a reinforcement is both tougher and stiffer. So mechanical and durability characterization of the new material, new textile waste microfiber reinforced cement composite for building applications. So in this textile reinforcement like steel fiber being used more in concrete components to improve their performance. So textile reinforced concrete is generally used for primary reinforcement. TRC beams have different post-cracking flexural behavior than SRC. And the experimental investigation of single and hybrid fibered reinforced concrete under drop weight test. In this study, extremely impact energy and initial strength of concrete using with different materials like forta, basalt, and batch fibers under penetration of impact loading. In this result, the hybrid fiber reinforced concrete had 45.3 and 49.7% higher overall strength and energy absorption than single fiber concrete. Next, the summary of the literature review. In the summary of the literature review, these fibers are high tensile strength used to increase the tensile strength of the concrete. In addition to the fiber to concrete, significantly increases toughness and makes concrete more durable and observed by modes of failure of specimens. In order to increase the uh, fiber reinforcement, you have to increase the strength of the concrete. This textile fiber reinforced concrete can be suggested for rehabilitation of the deteriorated structures and the strengthening of existing RC structures. The specimen names in this photo, the first layer, second layer, and 3 layer. So AutoCAD layout of prisms with air glass fiber. In the first layer will be placed in 50 mm from the top, and 2 layer prisms. In the 2 layer prisms, the first layer will be placed in 25 mm from the top, and second layer will be placed in 75 mm from the top. And the third layer, the 3-layer prism. In the 3-layer prisms, will be placed in 25 mm from the top, and 100 mm from 100 mm, and 25 mm, 50 mm, and 75 mm. These are the specimen names. First, you have to cast a control specimen and a alkali resistant glass fiber reinforced concrete. This is layer 1, layer 2, layer 3. So casting and testing of the specimens, these are the casting of cubes and taking compression test and casting of prisms, and this prisms can be used to tested in universal testing machine. This is the photo for during casting process for placing of fiber. So flexural strength, enhancing the matrix strength requires a reinforcement that is both tougher and stiffer compared to the matrix and susceptible of altering the composite failure mechanisms in the efficient manner. So impact strength, the dimension is old. The dimension is 150 mm and 65 mm height. These are study in control specimen and layer 1, layer 2, layer 3. In this impact strength, we have to gradually increase for control specimen and layer 1 24.78 and layer 2 25.87 and layer 3 27.11. And other tests of 28 days compressive strength test and 28 days flexural strength test. So control specimen is gradually uh, decrease because of using of the number of layers of textile reinforcement, and also in flexural strength is gradually increase. It has more tensile strength. In the flexural test, we have to identify the tensile strength of the concrete. So first control specimen is 6.19 and layer 1 specimen is 7.22 and alkali resistance layer 2 is 8.65 and the third layer is 10.34. These are the gradual increase of the flexural strength of the concrete in 28 days. And the conclusion. And the study look out the effect of adding of alkali resistant fiber to material to see it many prevent it cracking suddenly and brittle. So the volume of the concrete mix is then supplemented with the alternating of layers of alkali glass fiber. Because of this, the flexural strength is significantly increased in comparison to control specimen because of bridging effect of the fiber mat has when it is placed in 3 layers of prism in specimen alkali reinforced glass fiber concrete 3. The flexural strength of the material is 10.34 Newton per mm square. This is the year of all the prisms when placed in flexure textile reinforced concrete will be in the state where the crack widths are restricted and typically higher resistance can be attained. This test involves counting the and also and have the take the hammer test. Drop hammer test is the final step in the determining the impact strength of the specimen. This test involves counting the number of blows that are delivered to specimen. The specimen 3 has a great impact strength for 27.11 joule, which is the highest. Because it contains 3 layers of alkali resistant glass fiber, concrete will have greater capacity for absorbing and redistributing energy. As a result, one can draw the conclusion that encouraging the use of TRC concrete in mechanical applications is possible. These are the references I have studied. Thank you.
Am I audible, Mr. Vinith?
Yes, sir. It's audible, sir.
Somewhere you have mentioned that the inclusion of fiber,
yes, sir.
You will get tensile strength improved. Is
Yes,
it
sir.
correct?
Yes, sir. Correct, sir.
Tensile strength improved or flexural strength improved?
Flexure, sir. Flexure.
But how you are saying that it is a tensile strength? Basically, what is the inherent property of concrete when subjected to load?
Sir?
Whether what type of failure it will take? Is a brittle failure or a ductile failure?
It's a brittle failure, sir.
Then if you are adding fiber,
yes,
you
sir.
will get a brittle failure or some other failure.
Brittle failure, sir.
ஃபைபர் ஆட் பண்ணதுக்கு பின்னாடியும் brittle failure தான் ஆகுமா?
இல்ல சார், ஃபைபர் ஆட் பண்ணதுக்கு அப்புறம் வந்து டக்கலா தான் சார் இருக்கு. அந்த லேயர் 3 வந்து பிரேக் ஆகல சார், ஃபுல்லா பிரேக்
Ductile
ஆகல.
property is related to which property? Which strength?
Sir.
Fiber always enhance in the flexural strength and always is supporting the ductile property failure, right?
Okay, yes sir, right sir.
You mentioned that impact strength.
Yes sir.
Drop hammer setup.
Yes sir.
Which code you referred? Otherwise, the drop hammer setup is based on which code? Can you say that the code, whether it's Indian code or foreign code?
Indian code, sir.
Which code?
Yes sir.
Tell me which code.
Code.
What is the size of the specimen you have cast?
150 mm diameter, sir. 63 mm height, sir.
150 mm diameter,
63
mm
height. Yes sir.
What is the weight of the hammer?
So weight of the hammer.
And from how much height the hammer will be dropped?
So weight of the hammer is 2.5 kg, sir.
2.5 kg.
Yes, sir.
How much height it is dropped?
The 300 mm, sir.
300
1 feet, yes, sir.
So these all mentioned which code?
Code.
You should know, na?
Yes, sir.
Civil engineer always to refer some code.
Yes, sir.
Whenever you are going for any test.
Yes, sir.
You please refer ACI I44.2R. Okay, it is
okay,
not
sir.
Indian code.
Okay, sir. Okay, sir.
The code is very specifically for fiber reinforced concrete.
Okay, sir. Okay, sir.
You are a UG student or PG student?
UG student, sir.
You please contact with your guide, Dr. Karthikeyan.
Okay, sir.
Hmm?
Okay, sir.
Whenever
Yes,
you
sir.
are coming to a public forum, you should have a 100% facts and the supports.
Okay, sir.
Hmm?
Yes, sir.
Hmm.
Sir. Okay, sir.
Okay.
Thank you, sir.
Thank you, Vinith. Thank you, sir. So next paper ID C035, Haiti, ma'am.
Yes, ma'am.
Okay, ma'am. You can present now, ma'am.
Ma'am, my screen visible, ma'am?
Yes, ma'am.
Ma'am, I'm Khyati, ma'am, from RMK Engineering College. I'm here to discuss about the topic utilization of demolition waste and recycled material in building construction. Definition of construction and demolition waste. This is the we get when we do remodeling, repair or demolition of any civil structure. These are the literature reviews. These are the few literature reviews I read, ma'am. From the literature review one, I conclude that using of materials which are waste and recycled means the concrete waste and the brick waste gives us the strength and also it reduces the landfill. I mean, it conserves the landfill space. From the second literature review, we conclude that waste produced through construction and demolition throughout the world considers means it include many wastes including steel, concrete, glass and some other materials. Because of using these waste materials, we don't need to produce the new materials. By that we can control the carbon dioxide releases while we manufacture the new materials. Secondary waste consists of concrete, brick, timber, glass, steel. Concrete demolition we get when we tear down the when we demolish the concrete buildings and structures. By concrete waste, we can recycle by sorting, crushing, and giving into recycled aggregate. This can be used to throw material. Recycling is cheaper and economical than taking the rubber to a landfill. We can soak it and we water off. Then we can we scrub it with the wire brush. By that we can get cleaned bricks in a pile and we can just repeat this process and we can make the new bricks. Or else we can use it as aggregate. Can be waste can be used. You can give it to small parts, but it can also be used for inside the house or taking outside the class. So in demolition, glass one purpose is it can be used more times. By this pie chart, we can tell that concrete will have the most weight in demolition. Next we have bricks. Next we have steel. benefits of doing this project, we can recycle and reuse the construction waste so that we can expand the lifespan of the materials. With, by that we can reduce the need of manufacture of raw materials for new products, decreases the demand of landfill space. It also conserves energy and resources, and it reduces pollution, means the extraction of carbon dioxide and other gases, making production process. It saves the materials. It controls. By this we conclude that using automation in new materials reduces the use of raw materials and also conserves energy and natural resources. Steel, from demolition we can get 93% of steel which can be reused. Glass 27%. We get 27%. Brick 50 to 70%. If its strength is, we can reuse it. Concrete up to 30%. In the mix of concrete, we can use the recycled concrete up to 30%. This was the references I referred, ma'am. Thank you.
Miss Kaiti,
Yes, sir.
am I audible? It is a review paper or experimental paper or a research paper?
Review paper, sir.
You are with the capacity of PG student or UG student?
UG, sir. UG student, sir.
Okay, you have shown that C&D waste, construction and demolition waste.
Yes.
Okay. Have you checked that flakiness index and elongation index? Because even though it's a review paper, you're supposed to have some tests you should have carried out. Have you carried out that flakiness and elongation index test?
We've gone through some journal papers, sir. By that, I completed.
So what should be the both index percentage when if you want to use in a concrete or structural construction C&D waste? Do you understand what I am asking
Sir,
you?
for concrete.
Suppose
Yes,
you are
sir.
using C&D waste in a concrete, what should be
Yes, sir.
the percentage range, flakiness index and elongation index?
Sir, for concrete, it should be 1.8. I mean, elongation index, the aggregate we get from the concrete waste should be 1.8 times than the mean dimension, sir.
No, I am not asking
In the
that
length, sir.
the result you should have some percentage. Beyond that percentage, the aggregate should not be used to in a concrete. Some percentage is there. It may be 30% or 35%, something like that.
30%,
And one more
sir.
thing, you have
Concrete.
mentioned that timber also you are used. Timber you are using in C&D waste?
Means
Because
the
timber
waste
is a
timber we
light in
get, we can
weight.
use for flooring, sir.
Timber. You will use it directly or after treating the timber?
After
Because
treating it, sir.
what liquid you are using for treating the timber? பிகாஸ் நான் தமிழில் சொல்லுவாங்க இல்லையா நமத்து போயிடும் கொஞ்ச நாள் ஆனவுடனே நீங்கள் ஃப்ளோருக்கு யூஸ் பண்ணுறீங்க அது வாட்டரை அப்சர்வ் பண்ணும் கண்டிப்பாக அது நமத்து போயிடும் நமத்து போனால் வந்து அவ்வளோதான் அது டேமேஜ் ஆயிரும் அப்போ அப்படி ஆகாமல் இருக்கிறதுக்கு வாட் ட்ரீட்மெண்ட் யூ வில் கிவ் வாட் இஸ் தி ப்ரொசீஜர் டு கன்வெர்ட் திஸ் லைவ் டிம்பர் டு construction timber, that means as aggregate if you are using?
I don't have actual idea, sir.
You have to find out and you have to give some lot of supporting.
Okay.
Just you have done, I think you have carried out that review. The review paper, whether they have given correct statement or not, some of the work we have to carry out, and then we have to present. It is your UG project work?
Yes, sir.
Then please contact or discuss with your guide.
Okay, sir.
Then find out the pitfalls.
Okay,
Okay.
sir.
Okay.
Okay, sir. Thank you,
Carry
sir.
on. Thank you.
Thank you, ma'am. Thank you, sir. Next paper ID C041. Parthasarthi.
Yes, ma'am.
Share your presentation, pa.
Okay. Yeah. Good afternoon to one and all present here. I'm going to explain about my topic, an experimental study on paper block using Proposis juliflora as. Introduction. Proposis juliflora is commonly known as a Simum carvale in Tamil. It is a tree widely grown in many places in India. The utilization of waste material can be economical and eco-friendly alternative in nearby areas for pavement of road construction. In this project, using the useful manner, which will be available in affordable price. It is used in pavement of road construction. Objectives of the project: to judge the utility of proposed juliflora as a partial replacement of cement in paver block, and to check and compare the performance of standard paver block and proposed juliflora as paver block. Scope of this project is to partial replacement of cement with the proposed juliflora as on paver block, and to study and analyze the characteristics of paver block, PGS paver block. Literature review is the name of the journal is Construction and Building Materials. From the experimental investigation, it was observed that there is no such appreciable changes in the mechanical property of the cement concrete. When cement is partially replaced with PGA, and 20% of replacement produces similar mechanical property, conventional cement concrete mix. And next journal is International Journal of Advanced Research Idea and Innovation Technology. Most of the admixtures in market are available in the form of chemical combustion, but in this project we study the effect of PGS and replace the cement by 10, 20 and 30%. The fine structure of PGS fills the voids and provides superior core structure, and thereby improving the strength. And next journal is Elsevier. The proposed juliflora is an American mosquito introduced in India in 1876. The mosquito parts contains 21.30 sucrose and 14.70 crude protein. And next journal is Research Gate. From this paver block are cast using partial replacement of PGS in this experiment. Here we used M30 concrete mix for casting paver block using 0, 10, 20 and 30%. From this result, it is observed that the compressive strength increases gradually up to 20% replacement of plastic coarse aggregate and decreases at 30% replacement of plastic close. Yeah. Methodology: literature review, testing of materials, manufacture of paver blocks, curing of paver block, testing of paver block, result and discussion, and conclusion. Materials required are cement, fine aggregate. Fine aggregate is a common M sand. Coarse aggregate, 10 mm coarse aggregate is used. Water and Proposis juliflora as. Proposis juliflora as is obtained. Proposis juliflora as is harmful to the nature and the environment. It reduces the underground water table. By using this material, we can manufacture economical and eco-friendly paver blocks. It is obtained from a brick manufacturing place and sieved it in 45 microns, and the ash is obtained. Specific gravity of coarse aggregate 2.54. Specific gravity of fine aggregate is 2.6. Specific gravity of cement is 3.16. Sieve analysis of fine aggregate is taken. Casting of paver block. Casting for the specimen is done with a sample of following dimension. For paver block, the dimensions are 25 cm cross 12.5 cm cross 8 cm. it is used to do pavement of roads and pedestrian walkways. This is specimen details. Uh, we done a sample of 42 samples for this project. Compressive strength test. The apparatus are compressors of compression testing machine, which shall be equipped with two steel bearing blocks for holding the specimen. From this graph, the optimum value of the PGS is 15%. Here are the compression test results for 14 days and 28 days. For 14 days, PB15 is obtained the maximum result, and also for 28 days, PB15 is obtained for the maximum results. This is a graphical representation for the compressive strength test. And for water absorption test, it also 15% gives the optimum value. Initial weight of 15% is 6.130, and after curing of 28 days, 5.760 is obtained. It is 5% lesser than the ordinary power block. This is a graphical representation for the water absorption test. Result and discussion. In this experiment, 42 number of power block were casted and tested to compare the strength of a power block with the ordinary power block. Based on the experimental study and the results, the project of the following conclusions are drawn. The maximum compressive strength result is 16.22 Newton per mm square, and in 14 days, partial replacement of cement as PGS, 15% of replacement of PGS in cement gives the ordinary power block strength result. The water absorption value is 5% lesser than the ordinary power block. It proves the waste band wood are used as in cement can be make a eco-friendly power block. Hence we can use this power block for replacement of conventional power block. And the conclusion is the proposes Jolie Flora can effectively used up to 15% level of cement in production of concrete, increasing which leads to delayed formation due to the higher amount of SO3 content in PGA, which also hinder at late formation. PGA cannot be used as a replacement of cement at higher levels due to the higher amount of alkalis present in PGA, which exceeds the limitation of higher standards. Reference are these are the reference from IS 15658. We tested this. Thank you, sir.
Parthasarthi.
Yes, sir.
You replace the cement as or as series replacing some other material.
Sir, I partially replaced cement, sir.
Only. Cement
yes,
only.
sir.
Okay. Have you done the chemical composition of ash?
Yes, sir. From the literature review, I have taken, sir.
You should just show it.
This is.
Okay. But you have done that. You are using the ash, right?
Yes, sir.
This is a literature review value. But
yes,
whatever the ash you produced, have you gone for chemical composition?
Sir, no, sir. But I took a specific gravity test, sir.
But chemical composition also you supposed to do, na? What are the different chemicals are available? Whether it's compatibility with the cement or not? We should know, na, completely.
Yes, sir.
Then, what is the minimum size of ash?
45 microns, sir.
45 micron CV you are used.
Yes, sir.
So all are passed in 45 micron.
Sir, I taken only which are passed in 45 micron, sir.
You are used to that M sand or river sand?
M sand, sir. M sand.
What is the fineness modulus of that M sand?
Fineness modulus of the M sand.
And how much fines are available? Have you gone for sieve analysis for fine sand, M sand?
Yes, sir.
So that
here is the result, sir.
So have you calculated fineness modulus?
Yes, sir.
How much you got?
Fineness modulus. Sir, furtherly I will proceed.
The percentage of fine also you didn't mention how much is there. Okay. Have you gone for SEM analysis? What could be the shape and the shape of the particle of your ash, whatever your manufactured ash? Hmm?
No, sir.
You should do, no?
Uh,
Because whenever anything we are using in a concrete, we should know the shape.
okay, sir.
Whether that new introducing material supposed to be matching with the existing material. Otherwise, the bonding will be a big problem for that.
Okay, sir.
So, whatever things I told, please keep in mind and rectify it.
Okay, sir.
Okay.
Thank you, sir.
Now I call upon Mr. R. Deenadayalan to present your presentation. The paper ID CE034.
Good afternoon, sir. I'm talking about investigation on strength characteristic of self-compacting concrete incorporated in AR glass fibers. Objectives of that to achieve self-compacting concrete using silica fume and fly ash, to study fresh properties of self-compacting concrete, experimental study on self-compacting concrete, adding varying percentage of AR glass fibers. Uh, self Self-compacting concrete is a flowing concrete mixture that is able to consolidate under its own weight. It flows to a virtually uniform level under the influence of gravity without segregation, due to which it completely fills the space between reinforcement. Advantages of self-compacting concrete: low noise level in the plants and construction sites, eliminated problems associated with vibrations, less labor involved, faster construction, improved quality and durability, higher strength. Comparison of normal concrete mixed with self-compacting concrete. Normal concrete is high water cement ratio, higher coarse aggregate and fine aggregate ratio, cost slightly less than conventional concrete, lower amounts of sand. Self-compacting concrete, lower water cement ratio, lower coarse aggregate and fine aggregate ratio, cost slightly more than conventional concrete, higher amounts of sand. Literature review: Heba A. Mohammed, The Effect of Fly Ash and Silica Fume on Compressive Strength of Self-Compacting Concrete under Different Curing Conditions. Science Engineering Journals, July 2000. The results show that self-compacting concrete with 15% of silica fumes give higher values of compressive strength than those with 30% of fly ash and water-cured specimens for 28 days give the highest values of compressive strength. The results of studies this suggest that certain fly ash, silica fumes, and lime powder combinations can improve the workability of self-compacting repair motors more than FASF and LP alone. Materials used for self-conveying concrete: fly ash, silica fume, AR glass fibers. Glass fibers are made of silica oxide with addition of small amount of other oxides, high strength, good temperature and corrosion resistance and lower price. Used as reinforcing materials in many sectors. Methodology, literature review, material collection, property study of materials, castings of specimens, curing of specimens, testing of specimens, comparison with the conventional concrete, results and discussion. Next design of SCC is making 7 mixes that were developed in the experiment. A mix ratio of 1 is to 1, 1.86, 1.67 was used with the water binder ratio of 0.45, cement ratio of contents 50 kg per meter cube, water content 229 kg per meter cube, coarse aggregate 800 kg per meter cube, fine aggregate 930 kg per meter cube. Mixed proportion for identification silica fume and fly ash for slum test on is self-compacting concrete mix as grafton. Test on self-compacting concrete. Test on fresh concrete. Slum flow test, L box test, U box test, J ring test, V funnel test. Fresh properties of optimum SCC mix with the various percentage of AR glass fibers. Properties related to self-compacting concrete. Slum flow, L box, U box, V funnel, ring funnels are a percentage. Test on hardened concrete, compressive strength test, split tensile strength, flexure strength. Compressive strength on SCC, compressive strength up to 28 days. Silica fume fly ash were identified. Flexural strengths on SCC mix. Flexural strength are up to 7 to 28 days at a megapascal. Conclusion: the experimental observation proved that the replacement of silica fume by 5% and the fly ash by 10% in cement is found to carry higher loads than that of other combinations. Adding AR glass fiber to the self-compacting concrete has provide flexible concrete. It also enhanced strength. The higher the percentage of glass fiber, the higher concrete's compressive strength, flexural strength, and split tensile strength values. Thank you, sir.
Alan,
Sir.
You have used the glass fiber, right?
Yes, sir, glass fiber.
What is the aspect ratio of your glass fiber?
Aspect.
Do you know that? What is the meaning of aspect ratio?
Yes, sir.
What is the aspect ratio of your glass fiber?
Aspect ratio 7.05.
7.05. Whether you used macro fiber or micro fiber?
Macro.
Microfiber.
Yes, sir.
But in the picture you have shown that the fiber is visible. But in macro fiber mean it will be looking like a powder, but when you are looking in the microscope only, it will be fiber. You are using this is the fiber you use, right?
Yes, sir. This fiber
Picture is taken from net or your own fiber.
Own fiber.
So this photo is your photo.
Yes, sir.
So suppose you are using fiber while mixing a concrete,
Yes, sir.
you might have faced one problem. What type of problem you might have faced? Suppose in a drum mixer or water mixer,
Okay, sir.
when you along with the concrete, if you are adding the fiber,
Yes, sir.
while mixing, you might have faced one problem. What problem you faced? Whether you face any problem or not, first of all.
Problem is faced.
என்ன problem வந்துச்சு உங்களுக்கு? Have you got a balling effect?
Yes, sir.
எல்லா ஃபைபரும் ஒரு இடத்துல போய் மொத்தமா சேரலையா உங்களுக்கு?
ஆமா சார், மொத்தமா மிக்சிங்.
அப்ப சேர்ந்துச்சுன்னா அப்புறம் எப்படி how do you ensure that all fibers are mixed along throughout the concrete? And you use that silica foam, right?
Yes, sir. Silica film.
Already you are using a fly ash.
Yes,
Then
sir.
what for you are using silica film?
To strengthen.
Strengthening. In
Yes,
what
sir.
way? In what way it will strengthen? What is
Self-compacting.
what is the basic property of silica film?
Self-compacting strength.
Self-compacting. What is the size of aggregate you have chosen for self-compacting concrete?
20 mm.
20 mm.
Yes.
Is it okay?
Okay.
Hmm?
Okay.
Please check.
Okay, sir.
Check with your guide.
Okay, sir. I'll check. Okay.
Because self-compacting concrete is all aggregate or concrete,
Yes, sir.
automatically they will go and settle, right?
Yes, sir.
Yeah, sometimes with 20 mm, you may not get efficient or effective
Okay, sir.
action.
Okay, sir.
There is some restriction is there.
Okay, sir.
What is the size of silica film you have used? For all material, particularly cement, fly ash, silica film, for that chemical composition, SEM analysis have you carried out?
Yes, sir. No.
You should have shown that SEM photo. Based on that, you can find out that what is the size of the aggregate, what is the shape of the aggregate, the chemical composition also. Have you gone through chemical composition? Because this is your project work, right? So in a report, this all thing you have to attach, right? Hmm. Okay, a lot of things are there. Please, as a presentation point of view, is okay.
Okay.
For a report preparation, you just யார் உங்க கைடு யாரு கலைமணி மேடமா?
Yes, sir. Primary.
அவங்கள்ட்ட டிஸ்கஸ் பண்ணுங்க. என்ன
Okay, sir.
இதில் நான் சொன்னதெல்லாம் கரெக்ட் பண்ணுங்க. அப்போ தான் வந்து உங்களுடைய ரிப்போர்ட் வந்து பர்ஃபெக்ட் ஆகும்.
Okay, sir.
ஓகே, ஆல் தி பெஸ்ட்.
Okay, thank you, sir.
First on.
இதுதான் லாஸ்டா என்ன இருக்காங்களா மேடம்?
இல்ல சார், முடிஞ்சிருச்சு சார்.
அதில் இந்த சிஇஓ 24 வரலையா?
வரல சார், அவங்க எல்லாம் ஆப்சென்ட் சார்.
அதே மாதிரி முன்னாடி சிஇ 002 அதுவும் இல்லைல்ல?
இல்ல சார், இல்ல
017.
ஆமா சார், அவங்கள இல்ல.
வந்தவங்க வந்து 1 16 அப்புறம் 32 34 35 40 41 அவ்வளோதானே? ஹலோ, நான் பேசுறது கேக்குதா மேடம்? கலைமணி மேடம், ராகவன். ஓகே ஓகே. இல்ல மொத்தம் எத்தனை பேர் வரல? 2 4 பேர் வரலையோ?
4 பேர் சார்.
10 அப்ப 6 பேர் வந்திருக்காங்களா?
எஸ் சார், எஸ் சார்.
சரிங்க மேடம், சரி.
Okay sir, thank you sir. We request all the participants to give your valuable feedback in the link provided. The certificate will be provided to all the paper authors within 3 to 4 days. The Google form link will be shared to you today in order to get the details regarding the authors and affiliation to issue certificates. The procedure for downloading the certificate will be emailed to you later. Now I invite Lima Market Madam to deliver the vote of thanks.
Good afternoon to all. On behalf of Department of Civil Engineering and the entire fraternity of our institution, first of all, I extend my sincere thanks to Almighty for making today's session 1 on the domain construction materials and technology a resounding success. I extend my heartfelt thanks to our session chair, Dr. A. Ravi sir, Associate Professor from Department of Civil Engineering, belongs to Mepkoslang Engineering College, Sivagasi, who spared his time to occasion this occasion and shared his valuable inputs to the session 1 presenters over online platform. Thank you, sir. I extend my sincere thanks to our principal, Dr. L. Ganesan, Vice Principal, Dr. S. Rajakarnagaran, and Dr. S. Dharmar, HOD of Civil Engineering Department, for their encouragement and constant support to conduct this session for our conference in a well-defined manner. Also, I thank all the presenters of this session for your active presentation. Last but not least, a big thanks to all the participants, faculty members, and students who attended this session. Kindly fill the feedback form to get the certificate. Thank you. Thank you all.
Madam, can I carry on, madam?
Yes, sir. Now we can
Yeah,
carry
fine,
on.
fine, fine, fine. Thank you.
Okay.
So, good afternoon,
Thank you.
participants. Good afternoon, professor. So, this is Chokalingam here.
Yes. சொல்லுங்க. Yes, I am listening.
Sir, this is for invited talk, sir. So, next session we're going to start, sir. Thank you, sir. Thank you.
Okay,
Yeah,
okay.
yeah, yeah, yeah.
Should I leave? Should I leave the session
Yeah,
now?
yes, sir, yes, sir, yes, sir. Thank you, sir.
Okay.
Thanks for your
Thank you.
valuable presence. Thank you, thank you, thank you.
Thank you.
Thank you, sir. Thank you, sir.
Thank you, madam. Thank you.
Thank you, sir.
So, good afternoon, participants. So, we will start the invited talk on the topic size effect on concrete compression or tension within a couple of minutes. So, please be online. Professor, Dr. Giovanni, sir. Professor, can you hear me?
Yes.
Yeah, fine, sir. Fine, sir. So we
Yes.
will start the
Good
session.
morning.
Good morning, sir. Good morning, sir. So right now, Indian Standard Time is 1:34. So we will start the session sharp by 1:45, sir. So sorry for the inconvenience. So we are with a delay of 15 minutes, sir. So really sorry for the
Okay.
inconvenience. So please be online. So once the just now the session was the first session of our conference was finished. So let the participants join to this link, and we'll start the session by sharply by 1:45 Indian Standard Time, sir. So we have just 10 more minutes, sir. So please bear with us for just 10 more minutes, sir. So participants, we will, as scheduled, we will start the invited talk on the topic concrete its effect under compression or tension load by 1:45. So please be online. So, good afternoon, participants. We will start the session. So, on behalf of Ramco Institute of Technology, I would like to express my great pleasure in welcoming all of you for the International Conference on Sustainable Technology in Civil Engineering and Applied Sciences 2023, sponsored by TechApps Consulting, Modern Scientific Company, Chendur Builders and Traders, Indus Instruments, Pramidias Academy, and AML Limited. Let me begin by thanking our institution for their untiring efforts and support in making this event a reality. At this moment, I am really privileged to welcome Dr. Giovanni Di Luzio, Professor, Department of Civil and Environmental Engineering, Politecnico di Milano, Italy. I am most delighted that he has been able to accommodate this event over online platform among his very busy schedule. Welcome you, sir. Welcome you, Professor.
Yeah, thank you.
Yeah. Let me take this occasion to introduce our resource person, Dr. Giovanni Di Luzio, Professor, Politecnico di Milano, Italy. Professor received his MS degree in civil engineering in October 1998 from Politecnico di Milano. After 1 year spent in the Italian Military Corps of Engineers, in 2002, Di Luzio obtained his Doctorate of Philosophy in Structural Engineering. In 2003, he had a postdoctoral research fellowship in the research group of Professor Sidolin and joined the Department of Structural Engineering at Politecnica di Milano in 2006 as assistant professor. After obtaining the Italian national qualification as associate professor in January 2015, he joined the Department of Civil and Environmental Engineering as associate professor in 2016. Professor Di Luzio have been teaching course of structural design at the School of Architecture and Society and Civil Engineering of Politecnico di Milano since 2004. He obtained the Italian qualification as full professor in May 2019. Professor Di Luzio has been visiting researcher at Rensselaer Polytechnic Institute, Troy, United States of America in 2006 and at Northwestern University, Evanston, United States of America in 2000 and 2012. He is a voting member of American Concrete Institute technical committees such as Committee 446, Fracture Mechanics of Concrete, and Subcommittee 209, Numerical Methods and 3D Analysis, member of CEB Fiber TG 4.5, Time Dependent Behavior of Concrete. Professor Di Luzio is a reviewer for journals published by American Society of Civil Engineering, Elsewhere, Springer, KCI, JSCE, ICE, and he was awarded as Outstanding Reviewer by many journals. He was a speaker at numerous conferences and workshops in the United States, Europe, and Asia. He is the author of more than 60 papers published in peer-reviewed international journals and international conference proceedings. Di Luzio is a researcher with more than 20 years of experience in the field of computational and applied mechanics, in particular for concrete and reinforced concrete structures. His research topics include linear and non-linear fracture mechanics, non-linear constitutive modeling of quasi-brittle materials, mechanical behavior of concrete under variable hygrothermal conditions, concrete creep and rate effect, moisture and heat transfer in porous materials, concrete steel interface behavior, anchors in reinforced concrete structures, fiber reinforced cementitious materials, thermally damaged concrete, and alkali silica reaction in concrete. He has participated in many international and national research projects. So with no further delay, I am having the pleasure to listening to our chief guest. Over to you, Professor. Carry on, sir.
Thank you. Thank you very much, Dr. Kuchalingam, for your kind introduction and presentation. Also, I would like to thank all of you for this kind invitation. So, let me see if I can share my screen. Do you see my screen? Okay. Okay. So, I think you can see the presentation, no?
Yes, Yes, sir. Your screen is perfectly visible, sir. You please go
Oh,
ahead.
perfect, perfect. So, okay. So thank you very much again for the invitation, for your kind introduction. So the title of my presentation is Concrete Size Effect Under Compression and Tensile Load. First of all, I would like to acknowledge the co-authors of the work that I will present. And so, first of all, I would like to thank Professor Gianluca Cusatis from Northwestern University, which is the co-author of the first part of my talk on size effect under tensile load. And then I would like also to thank my colleagues from Politecnico di Milano, Professor Muchacha and Professor Rosati, that contributes to the second part of my talk about size effect under compression. And also I would like to thank Dr. Lynn Van Wendner, that spends a few months as postdoc in Politecnico di Milano, and she's now senior structural engineer in basics in Brussels, Belgium. So the outline of my presentation is that I will just introduce very briefly the size effect, and then we will talk about my recent contribution on size effect under tension and size effect under compression. So about the introduction, so size effect is the effect of structural size on its nominal strength. Of the structure. So this is actually a very old problem, which is even older than mechanics of materials and structures. And the first statements about size effect were done by Leonardo da Vinci here in Milano in 15,000s. And he basically wrote that a chord is so much stronger as it is shorter. So these rules implies inversal proportionality of nominal strength to the length of the rope, which is of course a strong exaggeration of the actual size effect that we have. So later, about 115 years later, Galileo also talked about size effect, and in his famous book, which was the foundation of mechanics of materials, he wrote that if you take a rope and you cut the rope at various points, the remaining part is not stronger. So someone rejected the initial idea of Leonardo. But at the same time, he pointed out that size effect is manifested in the similar shapes of animal bones when small and larger animals are compared. So also Galileo highlighted the presence of some size effect. But what we can say about size effect is that until the 90s of last century, it was assumed that size effect, if it was observed, it was of statistical type. So it had to be of statistical type, so a Weibull type of size effect. But this is not the case of concrete, because Weibull statistical theory applies only to that structures that fail right-hand initiation of a macroscopic fracture, and second, have a failure only of small fracture process zone, causing negligible stress redistribution, such as the case of metal structures embrittled by fatigue. So, which is not the case of concrete. Concrete as quasi-brittle material are characterized by the existence of a large fracture process zone, with distributed micro cracks and damage. And this is not just the case of concrete. There are a bunch of materials that display this type of behavior, such as polymers, rocks, ceramics, bones, clays, and wood, paper, ice. So many material has this typical quasi-brittle behavior. So for which the statistical type of size effect does not apply. So the typical size effect for this material is due to stable crack growth of a large fracture, and this lead to a stress redistribution and the release of the stored energy, and this would create the size effect. And in this case, we deal with a deterministic size effect, which is not due to the different distribution, random distribution of the properties of the materials, but it is due right to the mechanical properties of the material. And so, about the tensile size effect, so when we deal with quasi-brittle materials, so we can characterize the behavior of this material looking at the zone right ahead the fracture, in which we have an high localization of damage and micro cracks. And this zone is typically framed as the fracture process zone of the material. And so, as I said, for quasi-brittle material, the size of this fracture process zone is not negligible, and typically has a dimension which cannot be considered small compared to the dimension of the structure, and typically to the dimension of the specimens that we use in our laboratory test to determine the material properties of concrete, for example. And so we can use the cohesive law to characterize the behavior of the material in the fracture process zone. A cohesive law is typically a relation between cohesive stress and crack opening. And the typical cohesive law displays softening, as we can see here. Exponential softening is the most reliable way to model the behavior of the cohesive crack bed material. But we can also use the bilinear approximation of this cohesive curve, but also we can simplify the behavior in the cohesive in the fracture process zone with a cohesive linear fracture law, which is here represented, and this typical curve, which obviously represents a simplification of the overall curve, but it is still important because it can characterize the behavior of the material, especially in the initial part of the cohesive initial part of the cohesive curve, which are the typical points which characterize the behavior of the specimen that we test in our lab. So in the test that we test in our lab, typically they have a stress level at the peak that typically is in the first part of the cohesive curve. And so the linear cohesive curve is a good approximation in order to characterize the behavior of the material, especially when we compare with the data that we have from lab. So what it is interesting to explore is what is the size effect curve which is obtained from the cohesive law. So if we use the cohesive law and we simulate samples with different size with the cohesive law, we would have a curve which characterized the size effect obtained with this cohesive law. And so we can express this function with this capital phi, which can be expressed as function of the size of the specimen divided characteristic length, and we can characterize the nominal strength of the samples that we simulate numerically with sigma and u, so which is nominal strength, so which is obtained by dividing the maximum load that is obtained in numerical simulation by the typical area of the specimen. So, for example, if we have a specimen under tensile, under tensile pure mode 1 tensile test, so the area is the cross-sectional area. So if instead is a 3-point bending, so we can divide by the elastic modulus of the maximum load by the modulus of the specimen in order to get the nominal strength of the specimen. F prime T is the strength, the tensile strength of the material that we have in the cohesive law. The characteristic length can be defined as proposed by Hillerborg, in which E is the young volume of material, GF is the fracture energy of the material, and F prime T is the tensile strength of the material. So this is the relation between the characteristic length and the mechanical properties of the cohesive law. So if we have this equation, what we can if we report the results of the size effect obtained with the cohesive law, this curve presents two properties. One is that for the dimension of the specimen d that tends to 0, so for small sizes, this equation tends to the plastic limit. Plastic limit is the nominal strength calculated with an elastic, purely plastic analysis. So assuming a uniform distribution of stresses equal to F prime T on the fracture process zone, and in this case, you have the plastic limit of and so this equation tends to the plastic limit for D that tends to 0. On the opposite, for large sizes, this equation tends asymptotically to a straight line. And so this means that if it tends to a straight line, this means that the limit for d that tends to 0 of the function phi minus a straight line is 0. And so we can, from this relation, we can calculate the two constants G0 and G1. So, for example, if we consider a three-point bending test, so this is a three-point bending test, this is the geometry of the three-point bending test, D is the size of the specimen, A0 is the depth notch, which is assumed proportional to the 0, so it's scaled in order to have similar geometries. One problem here is the solution refers to sharp notches. So sharp notches means that the thickness of the width of the notch should be 0 in order to have a sharp notch. But if it would be 0, then you would have stress singularity at the tip, and so this would make it possible to do numerical analysis. So as it is widely accepted for this type of analysis, the thickness of the notch is kept constant. It is assumed small, and as has been shown by many researchers, if it is enough shorter, so which means much less than the characteristic length of the material, the notch can be considered a sharp notch. And also to avoid the stress concentration that you have at the tip, so we assumed a rounded, circular notch tip with a radius which is the alpha of the crack width. And so, if we report in a plot, in this plot, the results of this numerical simulation, we see that for large sizes, all those points belongs to a straight line. So this means that the cohesive size effect curve as a straight line as an asymptote for d that tends to 0. But this is not the case for d that tends to 0. So for small sizes, we have a deviation from a straight line, and so all the points belongs to a different curve. This curve here that tends to the plastic limit that for this geometry is this value. And so the question is this straight line, this asymptote, the Bayesian size effect law? So the Bayesian size effect law, which is characterized by this expression, so this means that if is this the case, so K0 should be G0, and K1 should be this term here, in which G0 and G prime 0 are the dimensionless energy release rate that you can obtain from the linear elastic fracture analysis. G prime 0 is the derivative of G0. Both of them are calculated for alpha 0, which is the value of A0 divided by D, and A0 represent the crack depth, initial crack depth, and CF that we have in this equation is the effective fracture process zone length, which for the derivation of this equation, Bayesian assumed to be a constant. So assumed to be a constant, and so assumed to be a material properties. So this means that is constant for a certain material. So So let's verify that this is true. So if the Bajand size effect law is effectively the asymptote of the cohesive size effect curve. And so for this, we consider different geometry. So different geometry for mode 1 fracture. So we consider the center cracked panel, which is represented by this this geometry with this axis of symmetry. And then we consider the double edge notch panel, which is this geometry, in which the axis of symmetry is this one. Or if we don't have any axis of symmetry, we have the single edge notch panel, which is this one. And then we consider also 3-point bending test, but with two different span to depth ratio, one equal to 3 and one equal to 8. And so if we report all the obtained points in a plot f prime t divided the nominal strength, ultimate nominal strength square, and on the horizontal axis we have the dimension divided by the characteristic length. As we can see, we have all those straight lines that represent the asymptote, but they are different. So different geometry, different asymptote. And the same, in terms of different curves, we observe also for small dimension of, so for small dimension. So all those points belongs to all those points belong to different curves, and that curves approaches to the plastic limit in different way, as we can see here. But surprisingly, if we consider the results of the size effect analysis with the cohesive crack law in this space in which x is given by G0 time the dimension of the specimen divided G prime 0 time the characteristic length, and for the y we consider the square of f prime t divided by the nominal strength of the geometry divided G prime 0. Surprisingly, we obtain that all those points collapse in a single straight line. So this means that in this space, the asymptote that the CSEC has is a straight line, and this straight line coincides with the size effect law proposed by Bajant if K1, so the K1 that we have here, is equal to 0 point in this space, is equal to 0.44. However, this is not the case for D that tends to 0, in which still the curves do not belong to the straight line. So, so this means that the cohesive size effect curves behaves differently from the Bajant size effect curve. And we should say that correctly the cohesive size effect curve converges to the plastic limit. What it is also extremely interesting to observe is that also the dimension of the fracture process zone, which is obtained from the simulation, is constant. So as the size increases, the dimensions tends to be to reach a constant value. And this constant value in this simulation with the linear cohesive law, it is 0.71 times the characteristic length of the material. And also the stress at the tip. The stress at the tip tends to zero as the tends to zero. However, those analyses can leave some questions open, let's say some doubts, no? So, for example, we have assumed constant width notch. So this means that when we scale the geometry, actually the geometry is not perfectly similar, no? Because the width of the notch is not scaled with the other dimensions of the other dimension of the specimen, but this is kept constant. So this somehow can violate the geometric similarity between specimens of different sizes. And also, as we discussed before, constant width notch also does not give the stress singularity, which is what is required for the sharp notch. And so so try to study better these two points. What we can do is to coming back to the original English problem, for which he obtained that the stress singularity can be obtained as a stress concentration problem when the dimension of the notch tends to zero, and so he considered elliptic notches, as we can see in this figure, and the stress concentration is given by this relation in which rho is the curvature of the tip notch, and as this curvature tends to zero, you obtain the stress singularity that is what we have in sharp notches. So to take into account this effect, so what we did is to consider now specimens with elliptic notches, as you can see here. And in these elliptic notches, what we assume is that the ratio between the crack depth A and the crack width B is kept constant. And so this means that since A is scaled with D, also B is scaled with D. So this means that the geometry that we obtain scaling the specimen geometry are perfectly similar. So also the notch is scaled. And with those type of notches, we can also obtain the sharp notch solution, which is the asymptotic solution when the ratio A over B tends to infinity, so which means the radius of curvature of the tip notch tends to zero. And so in this case, we have the size effect of type 2, and so the size effect that we have just seen from the cohesive size effect curve and from the Bajaj size effect law. And also we have also the other limit situation in which this ratio tends to 0, and so in this case the curvature tends to infinite, and so this means that in this case the notch tends to a flat surface, and so in this case we have the size effect of type 1, which is size effect characterized by crack initiation from a smooth surface, for which we apply the elastic limit. So to study the behavior of those geometries, we consider two different structural configuration. So we consider the center cracked panel. So those are boundary conditions. This is the elliptic notch that we have in this geometry, and also we consider three-point bending configuration, as you can see in this plot. And to study the effect of the A over B ratio, so we consider different value for A over B, and so we start from 0.5, 1, 2, 5, 8, 15, and then for the case that tends to infinite, so we have a sharp notch configuration, and so sharp notch configuration. For that, so we have the results that we have already discussed. And so, those are the geometries that we use in the simulations, and we determine the peak load for 16 different sizes, starting from D, which is the depth of the panel equal to 5 millimeters, and we doubling this dimension for 15 times up to a D equal to 163 meters. And the numerical analysis were performed using a linear cohesive crack law with the properties that you can see here for Young modulus, fracture energy, tensile strength, and so with those values we have a characteristic length which is 153 millimeters. And so what after performing all those analyses, we reported all the results in this double logarithmic plot, in which what we can see is that those are the results for the center cracked panel. And so we can see that for D that tends to 0, all the simulations, all the different geometries, so with different aspect ratio for the notch, for the notch, tends to the same value, which is the plastic limit. So the plastic limit for this geometry is 0.875, and so all converge to that point. But then we see that increasing the dimension, what we observe that is that all the points belongs to the same curve, but then the curves starts to deviate to this common curve at for different value of the dimension, which depends on the ratio A over B, and the smaller is the value A over B, the higher is the value of the deviation that we observe. And this deviation then tends to an asymptotic constant value. This asymptotic constant value is the elastic limit. And this elastic limit, surprisingly, coincide with the stress concentration value that you obtain for those geometries. So In the case of the center cracked panel, we can calculate the stress concentration value, and we obtain that the elastic limit corresponds to the value of the concentration stress when the value of the concentration stress reaches the tensile strength of the material. And so for this geometry, we can calculate this value, for example, from the Timoshenko book. And so what we observe is that our analysis converge for D that tends to infinity exactly to the theoretical value that we expect for the elastic limit. But when there is the deviation from the curve, the common curve, to see that we can plot the slope of those curves, and if we plot the slopes of those curves as function of the crack width divided the characteristic length, what we observe is that basically the function starts with a negative slope, and this negative slope inverts its trend for a value of 2b over the characteristic length equal about to 2, as we can see here. So this means that we have a deviation from the common curve when b, so the alpha of the crack width, is equal to the characteristic length of the material. Same results we obtain for the 3-point bending test, 3-point bending simulations. So in this case, the elastic limit cannot be calculated because there are no analytical expression in order to calculate the stress concentration that you have for this geometry, but the behavior is exactly the same. So for D that tends to 0, that tends to the plastic limit, and for D that tends to 0 tends to an elastic limit that depends on the ratio B over B0. And the same we can say about the inflection point. So we start to have a deviation from the common curve that tends to the linear elastic fracture mechanics solution for D that tends to 0, which is the solution that tends the case of sharp notches. So for sharp notch, the elastic limit is 0, approaches 0, and so the behavior is asymptotically to the linear elastic fracture mechanics solution. But the inflection is still obtained for a value of B, which is about equal to the characteristic length of the material. What it is also extremely interesting to observe, to look at, is the stress profile that we have in the fracture process zone. And so, here in the top, we have the solution for the sharp notch. So sharp notch, this is the adimensional value of the center line of this center line of the panel. Those are the results for the 3-point bending simulations. And so what we observe is that the stress at the tip for the typical geometry that we have in that we use it in the lab, so do not reach 0, but typically they are quite high, even higher than the alpha of the tensile strength of the material. But when the sizes increases, what we observe is that the stress at the tip tends to 0, and also what we observe, so this is in the adimensional term, so what we observe is that the stress tends to display in the stress in the fracture process zone. So the fracture process zone tends to display in a narrow portion of the of the center line. So this means that it tends to become smaller and smaller. And so this means that for the structure, because this is in the dimensional value, tends to be a point. And so this justifies also why we have the linear elastic fracture mechanics solution as the asymptote for the sharp notch situation. But if we consider blunt notches, so in this case we have A over B equal to 1. So we have a completely different situation. So we observe that the stress is increasing, D tends to reduce, but then tends to increase, tends to change, and so start to increase. And so at the very large value of D, what we observe is that the stress at the tip tends to FT. And so this means that this justify also what we observed in terms of the elastic limit. So then the failure is just a brittle failure with that is obtained when the stress at the tip reaches the tensile strength of the material, and again, fracture process zone is a point. So, which is what is also reported in those plots, in which we can see that for different value of A over B, the fracture process zone length tends to 0 for blunt notches, while for sharp notches tends to a constant value. And also the stress at the tip that tends to 0 for sharp notches, while for blunt notches tends to the tensile strength of the material. So, in order to simulate and characterize well the behavior of the material when the cohesive crack law is adopted, we proposed an equation, a formula, that is this formula that you can see here, that can reproduce the size effect behavior when a linear cohesive crack law is adopted, and for different geometries with blunt and sharp notches. And so we term this expression the generalized cohesive size effect curve, which has this expression, and this curve, as you can see, is function of the properties of the cohesive crack law. So it's function of F prime T and the characteristic length of the material, but is also function of the geometries. This is taken into account through the G and G prime, G0 and G prime 0. And also it depends to the geometry also with beta p and beta e, which beta e times f prime t is the elastic limit for that geometry, and beta p times f prime t represent the plastic limit for the geometry that you are considering. And then you have n and m, which are two parameters that needs to be calibrated based on the results of the cohesive Grech law analysis. And so this equation we term this generalized because can capture, for example, the size effect of type 2 that we have for sharp notches. So in this case, A or B tends to infinite, and so this means that we have the linear elastic, the linear elastic fraction mechanics solution for D that tends to 0. So the elastic limit is equal to 0. So BE is equal to 0. So if BE is equal to beta E is equal to 0, we have only just this term, which gives for D that tends to infinite this equation, which is basically the Bajal size effect, Bajal size effect law. 11 over 25 is 0.44, so the value that we have seen before. And also it converges correctly for D that tends to 0 to the plastic limit of the sample. But also it can simulate blunt notches. So if we have blunt notches, so this in this case the behavior also is well captured, because also for D that tends to infinite, so the asymptote is this one, and so this means that tends to the elastic limit, as we expect, as we have seen. And also the limit for D that tends to 0 is also well captured, which is the plastic limit. But this also can represent the case in which we have no notch. So this is an asymptotic case that we obtain as a limit case when A over B tends to 0. And so in this case, so you have to calculate the properly value of the elastic limit, and then you have the asymptotic value for D that tends to 0, which is the proper elastic limit that we have in this case, and also for D that tends to 0, tends correctly to the plastic limit. Obviously, this is a limit situation. So this is a condition that you can represent for A or B that tends to 0, because alpha tends to 0, and when you have this tends to 0, you can get the solution as a asymptotic case, because if you calculate G0 for alpha equal to 0, the value is 0. I forgot to mention that in the case of blunt notches, G0 and G prime 0, that we have this equation should be calculated making reference to the case of sharp notches for the proper value of A over B. And so here you can see how the generalized cohesive size effect curve can reproduce the numerical simulations that we have just presented, we have just seen. Oh, this is the purple line that basically overlaps the points that we obtain from the numerical solutions, also in terms of slope. This is for the center collect panel, the same for the 3-point bending simulations. The generalized cohesive size effect curve can fit also other data. For example, here we have the results of some simulation performed by Planas et al. In 1997 on 3-point bending configuration with the span to depth ratio is equal to 4 and with different notch to depth ratio from 0.1, 0.1, which is those triangles, to 0.7, which are those circles. And so again, so the GSEC, the generalized cohesive size effect curve, can reproduce very well those data. We can also compare the generalized cohesive size effect curve with the universal size effect curve proposed by Bajant. And here we can see for the two extreme case, the case in which we have A or B equal to 0. So in case we have no notch, any case in which we have sharp notches. And as we can see, for D that tends to 0, basically the two equations gives the same results, so they overlap. But the difference is for D that tends to 0. The difference is for D that tends to 0 because the generalized cohesive size effect curve tends correctly to the plastic limit, while the universal size effect law tends to different limits, as you can see here, which basically is not correct. We also compared this equation with experimental data. Although this was not the purpose of our work, because in our work we want just to derive the equation which represent the behavior of the structure if the cohesive, in this case, a linear cohesive law is adopted. But we can also compare with some experimental data. For example, if we consider those comprehensive data done by Hoover and Daya in 2013, in which they tested different specimens, this 3-point bending test, with different alphas, so different crack notch depth for very small value, 0.075 to 0.3. And so also in this case, the generalized cohesive size effect curve fits very well the experimental data in linear and logarithmic plots, and the best fitting was obtained with this value. And so this means that with this fitting, we are also able to identify the mechanical properties of this material in terms of a linear cohesive law. So we have the F prime T and the characteristic length. So this means also the fracture energy of this material. And so you can see that this equation is quite powerful because it can also be able to identify the material properties. So just a conclusion for this first part of my talk. So for specimens with blunt notches, the cohesive size effect curve are characterized by continuous transition from plastic behavior for small sizes to purely brittle behavior with failure at crack initiation for large sizes, which represent the elastic limit. For specimens with blunt notches in double logarithmic plot, the cohesive size effect curve feature a point of inflection where the curvatures transition from negative to positive, and this transition is obtained when the width of the notch reaches the value of 2 times the characteristic length. In case of sharp notches, in case of so the sharp notches, in this case we have no inflection point, and so the size effect curve approaches asymptotically the solution of the linear elastic fracture mechanics. For sharp notches, as we have seen, now the crack profile in the fracture process zone converge. We have seen stress profile at peak for different size, and in this case, for sharp notches, the dimension of fracture process zone tends to a constant value for all the geometries that we have seen, while for blunt notches, at the peak load, the fracture process zone first increases, but then shrinks, and asymptotically tends to a point, and the stress at the notch tip tends to the tensile strength of the material. And so this means that for blunt notches, the size of the fracture process zone is not a material point in this case, as is for sharp notch situation. And also we have seen with our proposed expression for the generalized cohesive size effect curve, which are able to reproduce very well the size effect of type 1 and type 2, and also how we can identify also the mechanical properties of the cohesive crack law from some experimental data. So let's come to the second part of my talk, which is the size effect under compression.
Sir, Professor, sorry for the interruption, sir. We have another session, sir. You please take 15 minutes more, sir. So
yeah, because I took too much time for the first part. So how many time I have?
You can, from as of now, you can take 10 more minutes to quickly cover your third part, sir. So really sorry for that. We have a pipeline of authors in the Google Meet link for the next session, sir.
Okay, sorry. Okay. So okay, so for compressive failure, so this is a different story, because concrete compression under failure is a complex phenomenon that has its size dependence, but this is typically discussed in literature, and especially in the codes. So in codes and standards, so they typically assume that the compressive strength do not depend on the size of structure. But also this is complex also from experimental point of view, no? Because when you investigate this type of size effect, you have to deal with geometry, so you have to double increase the dimension of the geometry that has to be tested under compression, and so this means that you will deal with very huge specimens, heavy, not simple to manage, to handle, and also to test, no? Because when you increase the dimensions, then you will need also very complex loading machine with very high loading capacity, which is not simple to find in labs. Also, from theoretical point of view, it is complex because it is also not easy to explain, no? Because we have many different microscale mechanisms. So microcracks that propagates from pores. We have microcracks generated by the difference of stiffness between the inclusion aggregates and the cement paste. Wingtips microcracks that originated typically in the ITZ and then deviates in the direction of the compressive load. Local crushing of pores or porous interface in the porous ITZ between the aggregates and cement paste. You have the bonding cracks that can be caused by shrinkage and hydration temperature, especially in the ITZ. And so you have a number of microscale mechanisms but all those microscopic mechanisms cannot explain the appearance of global fracture, global cracks that produce global fracture. And also, for example, in global fracture, you may have some mechanisms as splitting cracks, and in splitting cracks that typically are parallel to the direction of load, you have no energy released. And so this means that if you have no energy release, so you would have no size effect, as we expect instead, as we have seen, instead for size effect under tension. So to study this, we conducted a comprehensive experimental campaign considering cylindrical specimen without reinforcement, with different aspect ratio, and with diameter from 1000 millimeters to the 800 millimeters, and with different height from 20 millimeters up to 3.2 meters. So those are the testing machine that we used. So for the smaller specimen, we could use this MTS machine with a loading capacity up to 250 tons. Then for the longer specimens, we used another testing machine that we have in our lab, this Galbaldini testing machine, which has a loading capacity after 500 tons. But for the larger specimens, we do not have enough loading capacity in our lab, so we have to bring our specimens to another lab in another city, and so they tested with this huge testing machine with the load capacity up to 2,000 tons, as you can see here. And so you can see also here, those specimens that are quite big and not easy to handle. So those are the. So here we have a table which summarizes all the results that we have. Also for those specimens, first number is the diameter, second number is the height of the specimen, third number represents the number of the specimen. And so we have in this experimental campaign, we have different aspect ratio in terms of 8 divided the diameter, equal to 2, 4, and 8. And here in this column, we have the nominal strength, which are obtained from the test. And those are the coefficient of variation, which are quite small, except for this test. And these are the main failure mode, in which we obtain both shear band, as you can see here. We have some shear band failure and other axial splitting failure, as you can see here. Or for this larger one. And so the experiments confirm the existence of size effect. So we have huge size effect, as we can see here. And so to model this size effect, we explore the different size effect law that there are in the literature. The Bajan size effect law, which is not really capturing the behavior of the material for compressive state of stresses. For compression, Bajan proposed a different equation, which is this one that we rewrote in this form, and the coefficient is different, so there is a milder size effect with a asymptotic value for the compressive strength. And then also other formulas. So as you can see here, actually all the expression fits well the data that we obtain in our test. But maybe the compressive size effect curve is the one which has a more physical justification for this. For its derivation. Here we have the comparison with other experimental data. As we can see here, our data show with a little higher size effect. Maybe this is due to the fact that the specimens. So we tested the specimens quite old, because in order to avoid some aging difference between them, so we tested those specimens after 1 year after they were cast. But those were kept in the lab, so no particular measurement was adopted for the curing, so they were just left in the lab. So maybe there were some effect, especially for the larger one, due to shrinkage, and so to some eigenstresses that maybe would have reduced the strength of those larger elements. So in order to investigate better this, we did also some numerical simulation. So recently with Dr. Wendler, we simulate compressive size effect in compression, considering normal strength concrete and ultra high strength concrete. So here you have all the data about this numerical campaign that we performed.
Professor, sorry
Yes.
for inconvenience, sir. Shall we quickly give the concluding remarks for this compressive size effect, sir? So already we
Yes,
are.
yes, yeah. I'm done. Yeah, I'm done.
Yeah, really sorry for the inconvenience. We already.
No, sorry. No, so we use LDPM, which is the most reliable model for concrete, which is available in the literature. And so what we observe is this. So we have no size effect when no friction or low friction is used in the simulation of those tests, because typically what we observe is, as you can see, here is those vertical axial splitting cracks, and those associated to that there is no size effect. While there is some size effect when we use high friction condition, and here you can see the crack bands that forms in this situation. And here you see that we have some size effect, but this size effect reduces with the increasing of the aspect ratio of the specimens. And so to model this behavior, so we proposed also a new scale size effect law, scaling law that you can see here, which is also function of the aspect ratio S of the specimen. These are, and then when we compare with other experimental data, what we can see is that the size effect that we got from the numerical model is much lower than the size effect that is observed in the experimental data. And so this maybe is due to the fact that something was not considered in the numerical model, and this may be some eigenstrain due to, for example, the drying shrinkage, or as I think, so there is also effect due to the statistical size effect, which has a role in compression, which it does not have in tension. But this this will require more investigation. So thank you very much, and sorry for
It's okay, Professor.
being longer.
It's okay, Professor. Dear participants, we can take a couple of questions. If anyone is having questions, you please post your thoughts in chat box. So due to constraint of time, we are not able to take all the questions. So if you have any queries, you please post the same in chat box, or you please mail your queries to our conference mail ID. On your behalf, we will send the questions to our resource person, and we will answer the query. So in the meantime,
Yes. So if you have questions, yeah, I will be very happy to answer.
In the meantime, we can take 2 questions. So if anyone is having questions, you please unmute yourself, or you put your thoughts in chat box. Professor, one of the participants is asking a question: how to find fracture energy experimentally, especially the GF, what you said earlier, is easy. Cohesive size effect curve.
So this is not a simple task. So to measure the fracture energy experimentally is really complex, and so you can measure the work done in some test, but it is not simple. So my recommendation is to identify the fracture energy from the results of experimental from the results from the experimental through a cohesive crack analysis. So you do a cohesive crack analysis of your test, and by fitting the results of the test, you can identify the fracture energy of the measuring it directly from the experiments. I think is not a good way, because it can be source of errors.
Yeah, thank you, sir. So one last question from my side. As in case of cohesive size effect curve, you said that LCH, that characteristic length of specimen is determined based on that Young's modulus and fracture energy as well as tensile strength, EGF by FT squared. But hope you got my point. In this, but at the same time, some researchers are determining the characteristic length based on the size of the aggregate, especially alpha D max. So which one is correct? So based on type 2 size
Yes, no, but no, the characteristic length that I use is the characteristic length which is associated with the cohesive crack law, and in particular with the linear cohesive crack law. And so it's the characteristic length given by Hillerborg. No?
Yeah.
So if you use other expression to calculate the characteristic length, so those are approximate equation, approximate formula that you can use now in order to calculate the characteristic length. But the value that I use is the value which is related to the properties of the cohesive crack law, so to the mechanical properties of the material, and so is the value that are related theoretically to fracture energy and tensile strength. If then the problem is that this is not simple to measure. No, the problem is so when you have you are in real situation, real concrete. So how you can measure it? So there are a number of approximate equation that you can use to calculate that value. Okay.
Yes, sir. Yes, sir. Yes, sir. So we will wind up the session, sir. So thanks for your excellent session, sir. We hope our faculty members, students, and participants will take a lot of information related to concrete size effect, which will accelerate their research in their future endeavors. So for your kind information, in our institution, already our students and faculty members are working on type 1 size effect. So based on this lecture, we will try to concentrate on type 2 size effect in future also, sir. So for that, we will try to contact you definitely for a numerical model, sir.
Yes, yes. I'm available for any collaboration, anything, any questions, yeah.
Yes, sir. Yes, sir. So in the meantime, if any of the participants are having queries, means we will mail you, sir. So
Yes, yes.
thanks for sparing your time, sir. Thank you. Thank you. Thank you.
Thank you. Thank you. Thank you very much.
Karthikeyan, sir, you please carry on the session, sir. Thank you. Thank you.
Thank you. Thank you. Bye-bye.
Participants are requested to put your feedbacks in the following Google form link posted in chat box. Ravan sir, you can carry on, sir.
Okay, sir. Jokalingam, sir. Okay.
Thank you, sir. Thank you.
Sir, shall I screen? Hello, sir. Shall I share my screen?
Ma'am, please wait, ma'am. We have formal
Okay.
introduction. After that, you can present your paper. Please mute yourself, ma'am. Gopalakrishnan, sir. Sir?
Yes, madam, available. Yeah.
Good afternoon, sir. Yes, sir.
Good afternoon, ma'am. Good afternoon. Yeah.
Sir, shall we start the session, sir?
Yeah, you can proceed. Yeah.
Okay, sir.
Good afternoon to one and all present here. Myself, Raghavan, Assistant Professor, Department of Civil Engineering, Ramco Institute of Technology, Rajabalayam. On behalf of Ramco Institute of Technology, I would like to express my great pleasure and welcoming all of you to the second session of International Conference on Sustainable Technology in Civil Engineering and Applied Sciences 2023. It's my privilege and honor to welcome Dr. R. Gopalakrishnan, Professor, Department of Civil Engineering, SRM Easwari Engineering College, Chennai. The session chair for this session, Mrs. D. Darling Helen Lydia and Mrs. R. Kalaimani, Assistant Professor in Civil Engineering Department, Ramco Institute of Technology, as internal chair. Now I invite Mrs. D. Darling Helen Lydia, AP Civil, to give a brief introduction about our session chair. Ma'am?
Yes, sir. So Dr. R. Gopalakrishnan, sir, is currently working as Associate Professor in SRM Ishwari Engineering College, Chennai. He is holding his PhD from the year 2017 in Civil Engineering from Anna University, Chennai. He has completed BE Civil Engineering at Tyagarajar College of Engineering, Madurai in the year 2000, and he completed his Master's degree in Structural Engineering at Tyagarajar College of Engineering, Madurai in the year 2004. He has more than 26 years of teaching experience in various engineering colleges and 7 years in industry. His major areas of research are concrete technology, construction materials, geopolymer concrete, design of RC members. He has published 19 international journals and published 1 patent. He has also presented and participated in many international and national conferences. One of his remarkable achievement is that he has received Best PhD Thesis Annual Award 2018 from Indian Concrete Institute. With this brief note, once again, I welcome you to be the session chair for this second session, sir. Thank you.
Thank you, madam, for a brief, wonderful introduction about me. I congratulate the Ramco Group of Institution and the Ramco Institute of Technology and the Department of Civil Engineering for conducting this wonderful conference. I think you can proceed with your session. To start the session, madam. Thank you.
Okay, sir. Now I invite Mr. P. Ramshankar to present your presentation. The paper ID is CE037. Ramshankar? Madhurita? Madhurita, ma'am?
Paper ID CE037. Kindly unmute and you can present now.
Hello, sir.
Yes, ma'am, you can present your paper, ma'am.
Ma'am, actually, the college time is completed here, ma'am. I'm taking the bus now. Can I
Okay.
attend after some time?
Okay, can present at the last.
Okay, ma'am.
Kindly contact us, ma'am. Yes.
Now I call upon Miss R. Karshini to present your presentation. The paper ID is CE007. Kindly share your presentation, Harshini.
Okay, sir. Sir, whether my screen is visible, sir? Hello?
Yes, for your presentation, slide is visible.
Okay, sir. Thank you so much, sir. Good evening to one and all present here. Today I am going to present my topic is about the study on compressive strength of reactive powder concrete under various curing regime. And I am Harshini. I am pursuing my ME Structural Engineering in MEFCO Shalank Engineering College, Sivagasi. The content of the presentation is about the first we talk about the introduction of the part and literature review, methodology of the work, what we have conducted, and result and discussion of the result, and what is the conclusion of our project, and final part is references and introduction. What is reactive powder concrete means? It is comes under the category of ultra high performance concrete. It is also called as RPC. This concrete is described in Biosky laboratory in France, P. Richard and Shelley. And in this ultra high performance concrete, it does not contain any coarse aggregate. And another one beauty of this concrete is in this concrete, there is a very low water binder ratio to achieve the high compressive strength around 150 megapascal. So we have to, by achieving this compressive strength by using dense packaging theory and grading optimization technique, we prefer a low water cement ratio for this mix. And the ingredients which are used in this concrete are the cement, silica fume, swand, quartz powder, superplasticizer, and steel fiber optional. If we increase the more compressive strength, then we add steel fibers also. And what is the word reactive powder means? The material which are readily reactive to the concrete. Likewise, conventional concrete, in conventional concrete, the cement, fine aggregate, coarse aggregate, and water, these are the ingredients. Likewise, the reactive powder concrete having cement, silica fume, sand, quartz powder, and these are the main ingredient of the material. In the another one thing is important one in RPC are the material which are all the ingredient in very finer in nature. The material which are used in this concrete are less than 600 microns only. It can be satisfied with the help of some analysis. And also the application of this concrete are and increased corrosion resistant and low porosity and low permeability nature, we can go for RPC. And this concrete application mainly used in bridge structure and nuclear waste storage facilities to prevent the entry of gas and liquids. And these are to achieve RPC with the help of this principle. First one is the main thing, elimination of this coarse aggregate. Why we eliminate the coarse aggregate means, and to maintain the homogeneity of the mix, we have to eliminate the coarse aggregate. And for the purpose of, for the place of coarse aggregate, we have to fill the voids by using another material, that is quartz powder. And to reduce the air voids filled in the concrete during casting or mixing, by applying pressure, this can be removed. And microstructure improved by post set heat treating process. If we involve heat treatment of the concrete means, it will accelerate the pozzolanic reaction of the silica fume, and also it will alter the microstructure of the concrete. And next one is optimization of granular mixture means, we have to optimize the ingredient size particle. It is a very much important play in RPC. And improved ductility means, we will include small size of steel fibers or include, it is in optional. And maintain mixing and casting procedure, because the mixing and casting procedure play an important role in RPC. And these are the RPC composition: cement, quartz and silica fume, quartz powder, and superplastizer. In superplastizer, we have to achieve water cement ratio of 0.2. So we add superplastizer up to 4% of the weights of the cement. And the one of the best superplastizer which are used for in reactive powder concrete or polycarboxylate ether. It will discuss it in later. And the overview of our project is, we have to making the RPC by, there is no codal, and another one thing is there is no codal provision for RPC as per IS standard, but there is a standard for ACA standard and ASTM standard. So we have to follow these guidelines. We have to make own our mixed design by trial and error method only. Then only we have to achieve the enough amount of strength. And we have to testing the casting the specimen of Q specimen, and testing compressive strength under various curing rate, that is oven curing, autoclave curing, boil water curing. And boil water curing is comes under the IS code. That is the codal provision is IS 9013. And literature review: the first RPC concrete was made by Dr. Richard. In this paper, the dense cementitious matrix can be achieved, and high mechanical properties with the help of this all the ingredient. And they are achieved 200 megapascal compressive strength. And heraldlessly, the durability properties of the modified ultra high performance concrete with varying cement content and curing grammage. Due to the high cement content, we have to decrease the cement content with a partial replacement of any other pozzolanic material. Likewise, we have to partial replacement sand or any other material. It's also applicable in RPC. And these are the some of the reference. They also replace quartz sand for the river sand, and GGPS for the instead of the cement. And for improve the thermal properties, means we have to incorporate polypropylene fiber. It will reduce the spalling of the concrete, and also good bridging effect in concrete. And some of the literatures used metacline and fly ash for cement replacement. Sugarcane bucket also used in concrete. And these are the some of the literatures we have studied. And finally, the summary of the literature is, the addition of the nanoparticles to the concrete means it will increase the performance of the concrete. And use waste materials also incorporated in concrete, it will reduce the overall cost of the product. And mixing method means, because the mixing and curing technique is very much important in RPC, the mixing method is 4-stage method, which means there is a two types of process. There is 3-stage and 4-stage. In RPC, it is preferably 4-stage, and mixing speed is 50 RPM speed, and mixing time is minimum 50 RPM speed, and mixing time is 5 to 10 minutes. From this result, we have to conclude that some of the ingredients which are in the certain range only, we have to achieve our enough amount of strength. Using this condition, we have to derive the mixed ratio for the reactive powder concrete. And these are the methodology of your work. And problem identification: due to insufficient strength and insufficient ductility, the structure is vulnerable due to earthquake. And so we have to increase the strength of the structure, as well as reduce the and dimension of the thickness of the reduce the size of the member. So we have to provide the RPC. And these are the some of the applications which are used in the RPC. The RPC are used in real-time application also. And it is used in Canada's Sherbrooke Bridge, and a 60-meter bridge is constructed with the help of this RPC. And also many more applications are used in RPC in the world. And the objective is, we have to develop a mixed design by using trial and error method, and to utilize the pozzolanic active properties of the silica fume and other ingredients also. And this is the SEM analysis of the various ingredient. And first one is indicate the silica fume. Why we used in silica fume means, it will compared to cement, it will have a high specific surface area, so it acts as a secondary hydrate, and also filling voids and enhance rheology of the mix. And quartz sand, it is just like act as a fine aggregate, and it size ranges 150 to 600 microns only we have to prefer. And increase in granular packing leads to increase the density of the RPC mix. The only the cement and the quartz sand content is more in reactive powder concrete. And this is the quartz powder image. It will why we incorporate quartz powder means in RPC, to achieve high strength, we have to go for normal water curing. It will compared to and accelerated curing. So we for accelerated curing, the temperature is exceeding 100 degrees Celsius or 90 degrees Celsius. So we have to need additional silica to modify the binder and hydration process and alter the microstructure. We have to add in the quartz sand for maximum heat liberation. And these are the trial mix ratio for RPC for our case. And the RPC can be mixed by using the mortar mixer with a high speed. And RPC is one kind of self-compacting concrete. Then we mixing our specimen, making our specimen, and cured in various curing condition. In this work, we have to considered three curing condition. First one is a hot air curing condition. In hot air curing condition, the specimen is cured under 100 degrees Celsius, and as per Indian codal provision. And the boil water curing is there. IS second picture indicate the boil water curing condition, and this is the boil water curing condition. In this boil water curing condition, IS 9013, and the specimen is induced in 100 degrees Celsius boiling water for 3 hours. It will induce the hydration product and improve the strength. And third one is autoclave curing. It is in this autoclave curing 2 megapascal for 3 days. It will the steam is induced, the pressure is converted into steam. The steam is entered into the concrete. It will accelerate the hydration process. So then only we can increase the compressive strength of the concrete compared to water curing. And this is the compressive strength result for mixed proportion under various curing reg. And these are the three mixed ratios we are so far completed. And the highest strength is attained is the autoclave curing at 2 megapascal pressure at 3 days. And the mixed react the optimum curing condition and also satisfy the mixed designs also. And remaining specimens are affected by some of the issues. They are because very much high cement content in RPC, it will have a some shrinkage effect. These are the effect we have to follow. And this effect can be future, this effect can be reduced by with the help of fibers, small size steel fibers or any other fibers are introduced in this RPC. This effect can be minimized and increase the strength of the concrete. And finally, we have to conclude that the main objective of this go for accelerated curing is speed up the pozzolanic reactions of the concrete and to form the Dauber-Moiré gel formation and alter the RPC microstructure by post-heat treatment process. And the high cement content not only affect the production gut but also the negative impact on heat of hydration also. These can be micro cracks are generated at the top of the surface due to high cement content during heat of hydration process. So these microcracks can be arrested by with the help of fibers in future work. So the degree of autogeneous shrinkage will change depending on this mix proportion and it ingredients of the silica fume. It's play a major role. And the compressive strength is around 150 Newton per mm squared is achieved in this study by pore distribution method and dense packing theory. These values can be obtained by with the help of this ingredients. And the pore size of the materials by using SEM analysis. And the surface of the ingredients can be studied preliminary. And these are the references we are studied. And thank you, sir. Hello?
Yeah. Go to your compression slide.
Okay, sir.
Yeah, this is the how many days strength this one?
Sir, this is the how many days? 72 hours at 150 degrees Celsius, and we have to 2 days for
That
rest
means
conditions,
yeah,
sir.
3 days test. It is a 3 days test, correct?
72 hours means 3 days, sir. After 2 days, it will be for rest conditions, sir. Then we testing our specimen, sir.
Yeah, no problem in that one. No, this
Okay.
is the average of the three or individual cube what you tested.
Average of 3, sir.
Okay.
Yes,
That
sir.
means, say example 65.74. This is 3 days you were tested, correct? Then this is the another
Yes,
mix,
sir.
like that you are telling.
Yes, sir. Yes, sir. Yes, sir. Definitely, sir. It's another mix for RPC2. RPC1, RPC2, RPC3, it's a different
Okay, no
mix
problem.
proportion name, sir.
But if
Okay, sir.
you find this one, third one, RPC3, there is a lot of
Yes.
difference between 72 and 112. Okay.
Yes, sir.
Similarly, you can observe 94 to 145. What is the basic
Yes, sir.
reason behind this one? Can you identify, tell me, what is the basic
Okay.
reason behind this one? What is the mix RPC2 and what is mix RPC3?
Sir, for RPC2, we have to use water cement ratio as water as 0.1, sir. In this water as 0.1 means the material binding is very poor, sir, and we achieve particle density, sir. But due to hydration process, they don't have enough amount of water, sir. Though obviously the strength will somewhat decrease, and also the small micro voids are formed inside the cube, sir. But in RPC3, we have to increase the 0.18, sir. It will optimize that, and also silica fume content also we have to increase, sir, for to make increase the CaO, calcium oxide, and SiO2, sir. Increase the and heat of hydration process.
Okay, first of all,
We
what is
achieve,
mean by heat of hydration?
sir.
What is mean by heat of hydration?
Sir, the chemical reactions between these ingredients, sir, during heat treatment, sir.
So exactly, can you define me what is mean by heat of hydration?
During heat treatment, the how the concrete will behave with the help of this
During
ingredient heat
that means
treatment, sir.
what? No, that means you are saying that okay, in conventional concrete, whether we are doing heat treatment or not. Where is the heat
No, sir.
treatment come? No, in the
Sir,
normal conventional concrete also heat of hydration happens. Okay.
yes, sir. Yes, sir.
Heat treatment, where the word is coming in this normal conventional concrete.
Sir,
That means you do not understand the concept of heat of hydration. I think so. Can you
okay, sir, I
explain
will
what is
check.
meant by heat of hydration?
Sir, it is the hydration process during heat treatment as in acylated curing condition. It will say the heat of hydration, sir.
No,
It
ma,
will
no, no,
change in. Okay,
no.
sir, I will check, sir.
You refer all the your basic chemistry behind the cement content. Okay.
Okay, sir.
The heat of hydration is the when amount of water is added to the conventional cement or cement mix, lot of enormous amount of heat is generated. That we call as the heat of hydration. Okay, we are not going to do any heat treatment or something. Okay, you understand the basic
Okay,
concept.
sir. Okay, sir.
Whether we go for the any high reactive powder concrete or whatever different types of concrete, okay, all concretes will have the heat of hydration.
Okay, sir.
Okay. If heat of hydration occurs more only, then only cracks and all appear. We go for the other fiber materials and so on. Okay. So
Okay, sir.
you have done some work, but yet to be completed. Correct? I think. Okay. After
Yes, sir.
completing all your data, then you can come to your conclusion. Okay.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you so much, sir.
Thank you, Harshni, for your nice presentation. Now I invite Miss Pooja Damodaran to deliver your presentation.
Thank you, sir.
Paper ID CE028.
Yes, sir.
Kindly share your PPT, ma'am.
Is this visible, sir?
Yes, ma'am, your slide is visible.
Very good afternoon to one and all present here. This is Pooja Damodaran. I'm a junior research fellow from Department of Civil Engineering, Smart School of Engineering, Chennai. Here I am going to present a topic on my research topic on experimental investigation on mechanical properties and characterization of steel fiber concrete with bacillus subtilis. Okay, first of all, going to the introduction, I need to know. I need to say something. Why? What is the need of this research? I need to say about the need of the research. Okay, nowadays the demand for the concrete become over and over. Okay, whatever the maybe the rise in there is a rise increase in the price of construction materials, but the demand has become high. So demand becomes high. The what the quality they're giving, not about all. What the quality they are giving becomes reduced. Because of the reduced watering, it leads to the cracks in the concrete as soon as see so many buildings they build thousand years ago. It now without cracks is there, but before 10 within 10 months, okay, within 10 months what they are building, it gives a cracks. Why? What is the reason behind it? Okay, so the cracks, that the cracks spoils the aesthetic view of the structure. Okay, so to heal the crack, we are introducing the bacteria which is called bacillus subtilis, which is used to heal the cracks by producing the calcium carbonate. How the mechanism is, that is what we are going to see in this research paper. Uh, there's a bacterial concrete with the here I used the fiber which is called a steel fiber. Why you choose a steel fiber means which gives strength, which gives a improvement in the strength by compression wise and split wise and flexure wise. Okay, here I use the M30 concrete mix as per the IS code. uh, so in the normal concrete, I used steel fiber with bacteria. So bacterial with the steel fiber. For that concrete, I found the mechanical and microstructural properties, like mechanical properties like compression, split tensile strength, and flexural strength. And for the microstructural properties like same images, EDS, XRD, and FTIR methods I used to know the how the bonding. What is the need to study the microstructure properties means how the bonding between the concrete we need to know after casting. So I tested microstructural studies, and then it gives a result which is commendable, and ability of producing the bacterial concrete using the fibers in the concrete. So the methodology what I used here is first collected the various literatures from the literatures. I got a summary about the literatures, so they won't use the M30 mix with the steel fiber and bacteria. So I induced a bacteria with the steel fiber and the M30 concrete mix, and I formulated the objectives for the study. After that, I selected the mixed proportion. Then I casted and cured the concrete and found out the microstructural properties and mechanical properties of the concrete. At last, I discussed the results. So these are all the materials I used. What are the materials? I used the OPC 53 grade cement, and then zone 2 M sand, manufacturing sand I used here, and a 12.5 size coarse aggregate I used. I told you before itself I use a steel fibers by percentage wise to cement. So I here use the zigzag shape 30 length and 0.5 diameter steel fiber, and then a bacteria which is used to this study is Bacillus subtilis, which is a gram positive bacteria. This is how I formulated my objective. I studied the microstructural properties by introducing the Bacillus subtilis in the steel fiber concrete, and also I investigated the mechanical properties of the steel fibers concrete using Bacillus subtilis, and I noted the increase, where it increased, which percentage, which I actually used the from 1 to 5%, 1%, and from 1 to 5% addition of the steel fibers in the bacterial concrete. So where it gives the strength I found, and also whether the bacteria, the main reason why we using the bacteria is to heal the cracks, and also at last I found the whether the bacteria used in the concrete, it gives a result or not, it gives heals the bacteria, that heals the concrete or not, I found. So for that study, first this is how I mixed the concrete. First, a cement, first a dry mix I prepared using the cement and aggregates. After that, before the bacterial preparation is a separate, very big, and not a big. It is one of the task, because from the help of the microbiology department, I prepared the bacteria by using the centrifugation process. First, for that, I got the strips, bacteria spore strips from the high-tech media laboratory, and then that spore strips are incorporated with the nutrient solution in 48 hours, around in 37 degrees Celsius. After that, by using the mycology examination, we found the which are the bacteria, improvement in the bacteria, and then centrifugation process we did using 6000 rpm. At last, we got the 10 % cells per ml pure bacteria. After that, that bacteria is used with along with the water to the concrete, mixed with the concrete, and then after that, we cured for 7 days, 14 days, and 28 days, and tested by using the compression machines and fluctuation testers found. After that, by using that mixtures, we found the microstructural images. This is how the compression strength of the I actually three cubes of 150 cross 150 cross 150 size, as per the IS 516 2018 tested. For that, the compression strength of the steel fiber gives us result. Likewise, for the split tensile strength, gives a improvement. There is for this, and 1% gives a enormous improvement in the there is a little increase in the strength. So likewise, a flexure also did not calculated, and also same images from that tested cubes. I collected the materials inside the incorporated bacterial incorporated concrete and given to the microbiologist to give to note the same images. This image it gives the it gives a CSH level gel interfacial level between the bonding of the concrete. Actually, why I use the same image means it gives a how the bonding between the aggregates and cement is. It proves a bonding. It has high strength. These are all the interfacial level between that, and also it gives a good result of bonding. And also from that we are understanding the material, how the material is bonded with the on of one. This is ADS analysis report. What is the need to study this analysis report means it gives element composition. We are using the bacteria. At last end of the result, it should give the calcium carbonate as a precipitation. So we need to know whether the calcium the content, what are the content is there. So I used I studied those calcium content report by using the EDS analysis, and also I did the XRD and FTIR. And this XRD analysis gives the crystal structure of the material, and also it is also gives a present. It also gives a presence of calcium content. So in the FTR also, it gives a good, it is a non-destructive analytical technique. It is also used to identify the and characterize the chemical bondings of the materials. So this is all the total result is. What does that means? We need at the end we need to get the precipitation. We can also realize getting the concrete from the curing. From the curing, we can by touching the concrete layer, we will realize presence of calcium carbonates. It will be sticky. White color precipitations are surround around the concrete. So this is how the reactions are done. At the end by the presence of atmosphere, the presence of atmosphere, moisture from the atmosphere, and from the calcium, it gives a end result as precipitation of calcium carbonates. This is how actually for the cube we tested. We just given the this is airline crack only. When because why it is blood means we zoomed it. So it becomes too blurred. It is just like a hairline crack. After a certain time, I mean a particular time period, it the bonding between crack between the crack is healed by the calcium carbonates. So this is how we conclude the presence of the calcium carbonate is there by using the Bacillus subtilis bacteria, and also it increases the strength of the concrete, and according to the flexural strength of the steel fiber. Why I need to say one thing. Why I choose that steel fiber? Actually, here the reinforcement. It gives it because of the moisture content. It gives a corrosion to the steel. So that reinforcement. So here I used the steel fibers, which increases the strength of the concrete in 28 days compared to the 14th day. So it also shows the maximum tensile strength of the steel fiber bacterial concrete was at 1% gives a best result compared to the normal concrete conventional concrete M30 conventional concrete mixer. So at last it gives it healed the surface by producing the calcium carbonate precipitation. Thank you, sir. These are all the references, and then thank you.
Okay, very good presentation. You can go to your composition graph.
Sir?
Okay. What is the reason behind that blue curve? That is the 5% is having the values very low values.
Sir, when actually bacteria, when we increasing the bacteria, it also contain the watery substance. What it happens means the bonding between the cement, concrete, it becomes very low, sir. So when we continuously adding the bacteria, it gives a decrease in the strength, sir. At certain at the 1% level, it gives a good strength.
Wait a minute. See, if you see that one, 0% and 5% are almost same, correct? You see the graph?
Yes, sir.
0% and 5% are almost same.
Yes,
Correct?
sir. Yes, sir.
But 5% reduce, and in the 20 days it has not increased its strength, correct?
Sir. Yes,
Okay.
sir.
But in the case of 0%, this light blue color increase its strength. From the final conclusion from the graph, what is your conclusion? From the
Using
observation of this graph.
1%, using 1% of the bacteria gives a good result, sir.
Okay, that means minimum at least 1% is sufficient. But you went to up to 5. What is the purpose,
Yes.
or what is the reason behind going up to 5?
Sir, it's a trial and error method only, sir. Just a try, sir.
No, there should be some basic reason
It's,
adding the fiber in that one. Okay, what is the basic reason?
It's a strength. And also here we used the zigzag element, na, sir. It is what is the advantage by using the zigzag steel fiber means when we actually when we apply the load, it directly it tends to the concrete. When we put the steel that fiber in the horizontal way, it will what to say, இது வந்து
Okay.
தடுக்கும் சார்.
Okay,
ரெசிஸ்ட்,
what
இட்
is the
வில் ரெசிஸ்ட்.
okay? What is the steel fiber aspect ratio you followed?
Same 1%, 1%, 2%, 3%, 4%, up to 5.
No, what is the aspect ratio you followed?
Aspect ratio means according
What is
to
meant by aspect ratio in steel fiber concrete using steel fiber?
sir, can't understand what the question.
Okay, how
What is
much
the
percentage
aspect
of the
ratio
steel fiber you
in
use? How
fiber?
much percentage of steel fiber you use?
1%, 1%.
1% common for everything. Okay.
Yes, sir.
No, you have see, this is the bacillus substance you have added, correct?
Yes, sir.
What is the percentage of the steel fiber you added? 1%. That means in
One.
all the mixes same.
Sir.
In all the mixes same you added like that.
Yes, sir.
Okay, go to XRD.
Sir, XRD.
Okay.
Yeah.
The first one is the XRD,
Yes,
but
sir.
the figure is not at all visible, ma. Can you explain this figure first, XRD graph?
Actually, from this, that where I hear that it is a 2 theta value, and then this is a wavelength. It also gives the crystal structures, how the crystal structure is, and also that it gives a calcium content level. So in this rice gives a calcium content level, sir.
No, what I mean is, you have different types of elements available in the your what is the research or whatever you have shown the graph. Okay, but
Okay, sir.
depending upon the calcium you are explaining now, correct?
Yes, sir.
Okay, what I'm meaning is, first of all, the figure is not at all visible. You have to put it in a separate one, then only everybody can understand. Okay.
Oh, okay, sir. Okay, sir.
Then another thing, can you explain about this FTR analysis?
FTR analysis, actually,
Another
it
thing
is.
is, one second, ma. In the previous slide and all, you have made that. Go to the previous slide.
So this one, sir.
No. Previous slide. Every time you talk about steel fiber in the baseless subtils only, but suddenly you go to next slide. Go to next slide. Go to next slide. Yeah, suddenly. Wait. FTR graph. Suddenly you are saying that
Oh,
coconut fiber. I don't understand what you are telling.
sir, no,
There's
sir.
no mismatching.
Actually, it's a error. Sorry, it's a technical error, sir.
Okay, ma. Okay, thank you.
Thank you, sir. Thank you all.
Thank you, ma'am. Paper ID C037, are you ready to present? Is paper ID C026, Mr. G. Nagendran and Mr. V. Preeta, is that, are you there in this link? Mr. Nagendran? Yes, sir. Kindly present your paper. Kindly
Ma'am,
share your.
1 minute, ma'am. Actually, I need to say, sir asked that doubt, white coconut fiber. Actually, I'm doing
Okay.
one more research in the coconut fiber. Actually, I am using the different types of fibers here. So by mistake, I put that coconut fiber. Result is for a steel fiber only. Result is a steel fiber, but by mistake, it is defined as a coconut fiber. Sorry for the mistake. Sorry, sir. Thank you.
Nagendran, sir, you can present now. Kindly make it full screen, sir. Yes, sir. Nagendran, sir, kindly unmute yourself, sir. Nagendran, sir.
Ma'am,
Yes,
audible?
sir. Yes, it is audible. You can present now.
Okay, ma'am. Good evening to all. First of all, thank you for giving me this opportunity. I am Nagendran G. I am a PG student from Banariaman Institute of Technology, Satyamangalam, Erode.
1 minute,
In this
sir.
project, I
Nagendran, sir.
ma'am.
Kindly take 5 to 7 minutes for your presentation.
Okay, ma'am.
Okay.
In this project, I did was structural behavior of rebar shear connectors in steel concrete composite slab. First one is the introduction. In steel composite structure, shear connectors play a crucial role in the shear transfer between steel and concrete. They are generally used for the transfer of longitudinal shear forces across the steel concrete interface and also resist the displacement of steel and concrete at the connection, ensuring the composite action. Currently, creative innovation in the construction industry helps to overcome the challenges to the height and span of the structural system. Is the one of the solution of steel concrete composite structure is one of the best innovative solution. Next one is the scope of the project to develop a shear connector to withstand a strength and slip resistance in a better way and to increase a shear bond characteristic, and to understand the importance of shear connectors for various structural applications including bridges and buildings. Why composite construction is good? The reason why composite construction is often so good can be expressed in one simple way. Concrete is good in compression but steel is good in tension. By joining the two materials together structurally, the strength can be explained to result in a highly efficient and lightweight in design. The benefits of composite constructions include speed of construction, performance, and value. Steel framing for a structure can be erected quickly, and the prefabricated steel products can be put in the place immediately when cured. The concrete provides additional stiffness of the structure. Next one is what is meant by shear connector. Shear connectors are an essential element of composite construction. If it is to perform adequately, the main purpose of the shear connectors is to provide longitudinal shear resistance between the materials so that they act compositely and to facilitate the interaction between the two different materials and to allow them to act as one. Identifications of different of shear connectors. Normally in the field are using the normal shear connectors like stud connectors, angle, channel, and I shape. Now in this project we are used in the rebar shear connectors like V-shaped, open link, and circular, spiral, rectangular. What is mean with stud shear connector? Now the field are maximum used in the header studs is the most commonly used shear connectors in composite connection. Its popularity is mainly due to proven performance and easy in installation. Now the picture shows that is a header stud shear connectors now are using in this field. Next one is need for alternative to stud shear connectors. What is stud shear connectors is replaced to normal rebar shear connectors. The rebar shear connectors will have the advantages considering the fact that it can be fabricated to the required shape along the reinforcement for the slab. The wastage of reinforcement in the Indian construction industry is higher than in other countries due to the manual method for bar bending and cutting. Hence, rebar shear connectors can be made using rods available from the wastage of reinforcement as the length required to fabricate these connectors is minimal. The main functional requirements of rebar shear connectors is stronger than parts which are being joined. Failures should first place in the connecting members rather than the connection, which will ensure adequate warning before failure. This is the methodology of this project. First one is identifications of different shape connectors like normal shear connectors and rebar shear connectors, and experimental works is given. First one is casting of push-out specimen. The collections of material we are collecting in our college construction site at Institute of Technology. Next one is we are bar bending work in different shape in normal shear connector. Like first one is circular, spiral. Next one is V-shaped and open link. The three different type of rebar shear connectors are used in this project. This is a welding of I section. The I section is ISMP 200 and welded in our college of the three shapes. And patching and mixing of concrete is normal concrete for M25, and the placing and compacting of the bush-out specimens like and the curing after compacting after curing the curing concrete of the Canibax curing. Like next is specimen test for under monotonic loading. The bush-out specimens under monotonic loading were loaded using loading frame of 750 kilonewton capacity. The loading frame available in college campus. The load was applied in the upper end of ISMP 200, as shown in the figure like that. The loading frame, the bush-out specimen are extended in the black, and the load is applied to the gradually to the top portion of the rod. This is failure type of specimen is a different rebar shear connectors. First one like is open link, next one is circular, and third one is V shape. the test result with load-based deflection open link. This is the average result compared to structured connector. The load is maximum attained in 110 kilonewton. Is a slip of deflection is maximum is 4. Next one is shape is a minimum comparatively structured connectors like for various literature survey. It is only achieved in maximum load attained in rebar connectors like the 40. It is a circular spiral. The circular spiral is only the better result of comparatively structured connectors like in previous investigation. We are used in normal shear connectors is maximum attain the load in 100 kilonewton only, but we are using in the circular shear connectors maximum load is attain 125 in deflection of value is 3. This is a comparison of rebar shear connectors under monotonic loading for various type of shear connectors. It is a better result one for a circular. This is a conclusion of our project. In this study, 5 bush-out specimens were tested experimentally and analytically to study the shear behavior of rebar shear connectors under the static and fatigue loading. The failure modes observed for the experiment conducted when all the specimen was subjected to static loading is build failure only. It is viewed that the load slip characteristics and failure mode showed that low strength of the heat affected zone in the welded joint is a prime reason for the reduction. The analysis for studying the shear behavior of rebar connectors under static loading revealed comparable result with that of the experiment contact. In static loading, the circular rebar connectors should the maximum ultimate shear capacity of 56.56 kilonewton with a maximum slip of 51 meter under static loading. It contrasts the analytical revealed in normal shear connectors like 49 kilonewtons. This is the reference of the project, and final one is thank you.
Okay, good presentation. Go to your graph. Graph.
Oh.
Yeah, wait a minute.
Oh, okay.
From this graph, what you observed?
Sorry, we are observed in the maximum strain. We are using the 3 different types of rebar shear connectors like shape. For one is V shape and open
One
link.
second. This is the deflection curve or what?
It's a deflection curve, sir.
But because there is no unit and all, no, that is why I am asking. X-axis and Y-axis, no unit. Correct?
Yes, sir. Yes, sir. The x-axis is a deflection and y-axis load, sir.
But then you want to mention no.
Oh, yes, sir. Yes, sir. That's why.
Okay. From this graph, what your observance?
Sir, I am observed in the maximum load is attained in the attained in only circular shear connector only, sir. Comparatively normal shear connectors like headed shed.
But you can check the graph again. The V-shaped curve not at all reached in the half of itself is failure. Correct?
Yes, sir. Correct, sir.
What is the reason behind?
Sir, now I am studying now. The conclude is going on, sir. Not is completely.
Okay. So you think of that way also. Okay. What will be the reason behind that one? Because see the circular. See my opinion. I'll tell you. Okay. The circular there is the bond between it closes. Correct. The link has been closed.
Yes, sir.
Can you but understand? Yes. But in the V shape, if you check the shape of the V means. Not reached more. Okay.
Okay, sir.
But in the case of the open link, it has went up to both the circular and the open link almost reached the same. Compared with the circular, the open link also have the deflection more. The deflection should be less now. Then only the performance will be better. Okay.
Okay, sir.
You think on that way. Okay.
Okay. Thank you, sir.
Okay. But whether you compared with the analytical study and the experimental study?
Yes, sir.
Whether you have made any comparison?
It's a comparison to the normal shear connector, sir.
Yeah, the shear connector, how will withstand the load, everything you have to calculate manually and also experimentally. Okay. The experimental work you have shown, correct?
Yes, sir.
But you should also compare with the analytical method.
Oh, okay, sir. Now we process going, sir, by using ANSI software.
Okay, anti-software also you can do, and you can also do manually also. Okay.
Okay, sir.
Okay. Okay.
Okay, thank you, sir.
Now I invite Miss A. Dhanalakshmi ma'am to present your presentation, ma'am.
Okay, sir.
Okay, ma'am.
Good evening, sir. Whether my slide is sharing, sir?
Yes, ma'am.
It
Your
is
slide
visible,
is
sir.
visible. Visible, ma'am.
Okay, sir. Okay,
You
sir.
can
Thank you,
proceed.
sir. Okay, sir. Good evening, all. Myself, A. Dhanalakshmi, from PSR Engineering College, and my research topic is an experimental study on fiber reinforced foam concrete using hybrid fiber. Introduction: concrete is one of the widely used materials in building structures owing to its better composite properties with steel. The ingredients of the concrete is fully or partially replaced by a various types of substitutes to change its mechanical and durability properties. In that aspect, I chosen a replacement for cement using by silica fume and using two types of fiber. My topic is mainly focus on the non-structural members. So chosen the special type of concrete is foam concrete. Foam concrete is a type of lightweight concrete that implies
Your
the
voice is
density
very low,
ranges.
ma.
Okay, sir. Okay, sir.
Ravan, sir.
Okay, sir. Whether it is audible, sir? Foam concrete is a type of lightweight concrete that implies the density ranges from 300 kg per meter cube to 1850 kg per meter cube. I chosen the 1600 kg per meter cube for my research work. Foam concrete comprises cement, fine aggregate, and foaming agent, which imparts the lightweight behavior to the concrete. The use of supplementary materials for the cement, such as glass powder, rice ash, silica fume, bagasse ash, granite and marble dust powder, eggshell powder, etc. But to reduce the environmental pollution, chosen the waste material like fly ash and silica fume are utilized in this research work. Cement in this research work, cement, silica fume, fly ash, and sodium lauryl sulfate is used as a foaming agent, and polypropylene fiber and coir fiber combination was used in this work. Although several studies were made by the researchers in the structural element, the low density formed concrete found an application in the production of the multifunctional building components as the non-structural elements. So my aim is to achieve above 15 kilonewton per meter square. We can recommend it for the structural purpose. So I am going to trying the compressive strength for above 15 kilonewton per meter square. This paper aims to present the mechanical behavior of fiber reinforced foam concrete with a density of 1600 kg per meter cube. And the concrete comes under the category of brittle material. The use of discontinuous fiber will influence the strength characteristics. To overcome the effect, the addition of hybrid fibers were used. The main factor controlling the fiber reinforced foam concrete is to improve the mechanical properties, bond strength between the matrix of the cement and fiber, and volume of fraction of the fiber, orientation, etc. For lightweight concrete, the purpose of adding fiber is to reduce the crack propagation in the foam concrete, and also it possesses high modulus of elasticity. The fiber reinforced foam concrete can change the brittleness property of the concrete. Material used in this investigation, OPC grade of 43 was used, and silica fume fly ash class F fly ash was used. Both silica fume and fly ash was collected from the nearby agent, and sodium lauryl sulfate was used as a foaming agent. Polypropylene fiber having a 12 mm length and carbon fiber of 10 mm length fiber was used in this work. The manufacturing process of the fiber reinforced foam concrete. These are the materials I chosen. First, initially the raw materials are mixed for the 3 minutes, and the sodium lauryl sulfate and water mixed for to create the foam. The water to the foaming agent ratio is 1:20 was chosen, and the foam concrete is using the blender mixer used to generate the foam, and water mixture was used to create the foam concrete. Finally, we achieved the fiber reinforced foam concrete. This is our mixed proportion. In this, there are totally 12 proportions. In first one, the fully cement and fly ash was used. After that, so many investigations were done, and find out the optimum mix of 20% mix of for silica fume. So second mix contains 80% of cement and 20% of silica fume. And fly ash, here fly ash is used as a fine aggregate in this work, and two types of fiber were used, polypropylene fiber and carbon fiber. From the literature survey, chosen the 0.3% and 0.5% is the optimum. So ranges between the 0.3 to 0.5 percentages were chosen. For both, the first one is monotype of polypropylene fiber was used, and then monotype of carbon fiber. After that, mix FC9 to FC12 denotes the combination of the both the polypropylene fiber and the carbon fiber, initially from the 0.3 to 0.5 percentage of combination of the both. This is the result of the compressive strength. Here 150 by 150 mm cube specimen was used, and curing were then at the age of 7 days, 14 days, and 20 days. All the test result FC9 shows the optimum mix. FC9 denotes the 80% of cement and 20% of silica fume, then 100% of fly ash, and 0.2% of polypropylene, and 0.3% of carbon fiber. This is the graph shows the result variation of the compressive strength for all mixes. Due to the addition of the carbon fiber, percentage increases of 34% in the compressive strength was observed as compared to the conventional mix. The combination of both polypropylene fiber and carbon fiber, the compressive strength is optimum 0.5%, which contains 0.2% of polypropylene and 0.3% of carbon fiber. This presence of hybrid fibers gives the compressive strength of 14.6 megapascal, which is the highest strength in the foam concrete, which is 60% increment as compared to the conventional mixer. The higher percentage of polypropylene fiber increases the possibility of the pore connections in the matrix, which leads to the lower strength. So after 0.5% addition of the both the polypropylene fiber and carbon fiber, it reduces the compressive strength and mechanical properties. The next one is split tensile strength. This split tensile strength, the cylinder specimen of 150 mm and 300 mm height specimen was used. It is tested at the age of 28 days. In this, 2.3 megapascal is the highest value for FC9. FC9 having the 80% cement, 20% silica fume, and 0.2% of polypropylene. By the addition of the polypropylene, it shows higher tensile. So normally the addition of the fiber gives the higher resistance against freezing and thawing, and here we are using the synthetic fiber, so it acts as a secondary reinforcing material for the non-structural applications. So it increases the concrete durability and reduces the crack growth and increases the impact strength as well as the high tensile strength. By the addition of the carbon fiber in this work, the tensile strength is increases 41.6% of the tensile strength than the conventional mix. The polypropylene fiber compared with the carbon fiber exhibit lower tensile strength because of its lower strength of the fiber. Water absorption test, in this also, in water absorption there are so many variations we have seen. By the addition of the silica fume and the combination of both the fiber shows the same result, and the addition of 0% polypropylene and 0.3% of carbon fiber shows the highest water absorption, and lowest for without addition of the polypropylene fiber, and combination of both carbon and fiber shows the lowest water absorption. So from the figure shows that the result of water absorption in the fiber reinforced foam concrete, the observed range, the observed characteristics were achieved at the age of 28 days. The impregnation of the water in the foam concrete is difficult because of the uncertain microstructure formation in the hardened stage, because the here we are using the fly ash as the fine aggregate. It act as the fine aggregate as well as the viscosity modifying agent, because it is lightweight concrete that comes under the category of sulfate concrete also. So the fly ash characteristics that make suitable for the concrete to achieve high strength and high performance also. So the microstructure of the formation of the hardened stage is difficult, so the impregnation of the water is difficult. The incorporation of the silica fume reduces the water absorption in the fiber reinforced foam concrete. The water absorption of polypropylene fiber addition is gives 85% greater than the nominal mix. Heat map. This is the variation between all the materials and the testing of the parameters. From the result, the negative value shows that the gives the higher proper function have to be analyzed. In this, the cement and the foaming agent, addition of the foaming agent having the higher modular ratio. So for the next work, we have keen interest to adding the foaming agent and the cement content. Heat map of the fiber reinforced foam concrete shows the material variation. We can easily visualize the correlation between the variables of the material properties, such as addition of the silica, fume, cement, fly ash, polypropylene fiber, and carbon fiber, water, and foaming agent. As well as because of the addition of the individual components, we can easily identify the strength characteristics of the mechanical properties also, such as compressive strength, split tensile, and water absorption by using the heat map plot. In this for the heat map drawing, using the CBOR library was used to plot the correlation between the variables, and each variable showing a relationship with another variable. From the heat map, we find that the cement has a strong correlation with the water and foaming agent, and the fibers has a strong correlation with the fiber content. So in addition, the aspect ratio and the foaming agent proportion will change and redo the work. Conclusion: the compressive strength research indicates that the fiber content beyond the limit shows no improvement in its strength. In hybrid combination mix, 0.3% of polypropylene fiber and 0.2% of carbon fiber is performed better as compared to all the other mixes. The addition of polypropylene fiber shows the better results of the mechanical properties in all aspects, and the characteristics of the water absorption is increases with the addition of the fibers for both polypropylene and carbon fiber. Here, the silica fume is used as the chemical mineral admissions. It improves the mechanical strength, easily reacts with the calcium hydroxide with the cement. So, the characteristics of the water absorption also here plays a major role. It is inferred that the combination of 0.2% of polypropylene and 0.3% of carbon fiber shows the better results. Carbon fiber, in addition to that, in this work, polypropylene of 12 mm, which is comes under the category of long fiber, and for carbon fiber here using 10 mm. So the addition of the short fiber to the long fiber increases the fracture toughness of the interfacial zone between the cement and all other matrices we can see. These are the journals I referred for my research work. Thank you.
Okay, you are the research scholar or your PG student?
The research scholar, sir.
Okay. Go to your conclusion.
Okay, sir.
Yeah. You can the characteristics of the water absorption is increases with the addition of fibers for both polypropylene and carbon fiber. Okay.
Yes,
The
sir.
characteristics of the water absorption is increases up to what limit?
Sir, for polypropylene, 0.5 percentage, sir. Carbon, 0.3 percentage.
No. In the bottom, you are telling that it is informed that combination of 0.2 percentage of polypropylene and the 0.3 percent of the carbon source better. That means it satisfies all the properties. No, correct?
Yes, sir. Yes, sir.
Then you are saying that here 0.5 percentage.
Okay, sir. It absorbs the lower water.
No, the addition of another one. Say example, the addition of polypropylene fiber shows the better results of mechanical properties. Up to what
Yes, sir.
percentage the polypropylene fiber shows better results? That you got to say. What percentage?
Oh,
Keep on.
sir,
We should not.
combination.
Should not go for the statement. We don't
Okay,
give
sir.
the correct value. No.
Okay, sir. Okay, sir. Tried for only 0.3, 0.4, and 0.5 percentage alone, sir. And the combination of both the fibers only we tried.
Okay. Why you particularly selected that percentage?
Okay, from the literature survey only, sir. The
But
0.3
only
shows
should
the
not tell that. We should not say that I collected literature review. They have done. I also done. Should
Okay,
not say
sir.
like that.
Okay, sir. Okay, sir.
They have done means what is the purpose they have taken that particular percentage. You go to study the further topic. Further journals you go to
Okay,
study.
sir.
Then only you go to come to a
Okay, sir. I
conclusion.
will.
Sir, this much of
Okay,
percentage
sir.
and all they have added. What is the purpose they added? Why can't we add other percentages? The research is whether we get positive result or negative result, no problem.
Okay, sir.
Okay, that only
Okay, sir.
you want
Okay, sir.
to tell the word. Okay.
Okay,
Okay.
sir. Okay, sir. I will
Okay.
change. Thank you, sir.
Thank you, Dhanalakshmi ma'am, for your nice presentation. Next, I invite Mr. S. Dinagaran to present your presentation. Paper ID CE021. Dinagaran, sir?
Yes, sir. Shall I share with you, sir?
Yes, sir. You can proceed.
Sir, is visible, sir? Is it visible?
Yes, sir. Your slide is visible. You can start, sir.
Yeah, very good afternoon to all of us. So myself, President Nagaram, doing research scholar, Sarah Minister of Science and Technology, Karnataka. Here, my presentation topic is a review on infill frame structures with respect of various interface material. So, under the guidance of Dr. X. Muthukumar, SRM Institute, Karnataka, Chennai. So, infill frame structures are commonly used in the construction industry, and they consist of frame made up of steel or reinforced concrete, which is then filled with different types of materials such as brick, concrete, or timber. The infill material provides additional stiffness and strength to the structures, and it also contributes to the building's overall stability. So the infill material that are all used in the structures are all made of compressed brick materials, hollow concrete blocks that partially or completely cover steel or concrete frame, openings in the structure, and surround beams and columns made in that frame. Big units and mortar are combined to form a composite configuration for the masonry construction. Here the figure shows the first figure a bare frame and the second one fully infilled frames and the third one is partially infilled frames. The most frequent type of construction technology all around the world is the reinforced concrete with masonry infill. So here the figure shows on construction work is going on RC frame structures in Urupakkam. The presence of masonry infill walls in reinforced concrete building is common. Even today, however, in the design of new buildings and the assessment of existing buildings, infill is usually considered to be a non-structural element, and its influence on structural response is disregarded, and there is no proper contact between the frame and the infill. So the choice of interface material between the frame and the infill is critical in ensuring the stability and performance of the structures. The interface material must provide a strong bond between the frame and the infill, as well as it is accommodate any differential moments between the two components due to thermal or seismic effects. So when the wall is provided in the bare frame, then such type of frame is known as the infill frame. So infills are separated from the RC frame and do not interfere with the frame under lateral deformation. So all the lateral force on the building is carried by the bare RC frame alone. Here the figure shows the failure of the infilled frame during earthquake. So the various interface material can be used, including mortar, foam, rubber, grout, epoxy. Each material has an advantage and disadvantage, and the choice of the material depends on factors such as the type of infill, the expected loading condition, and the availability of material. Here, the specific articles, as I reviewed, they were published in here in the infill frame. So this is my methodology overall from the review of literature, masonry material and construction system. Based on the behavior of infill frames, I split into infill frame structures, unreinforced masonry structure, non-linear techniques, seismic behavior, and infill frame under lateral load and quasi-static loading. Here, the passive frame of earthquake is interface medium. Based on the interface medium, failure mode, retrofitting techniques, experimental work, and analytical work. Here, in the literature review, infill frame structure, author Umar et al. 2021 suggested that they estimated that this experimental investigation examined the use of polyethylene foam at the junction of infill maxillary wall and the surrounding RC frame to seismically isolate those structures. The author's segment says that the effect of various types of masonry infill and how reinforced concrete frames behave under lateral stress is discussed in this work. In case of non-linear behavior, author Charlotte 2026 explained that brick infills behave structurally and how to interact with the frame system that are susceptible to infill loads using the most up-to-date non-linear modeling techniques, and currently it's available. Seismic condition. Here, the seismic response on the infill masonry walls of 15-story reinforced concrete structure in region Nepal. The author X. Wong et al. 2018 says that old masonry structures and monuments that require modification in seismic regions around the world have been extensively investigated. Structures are planned and built with or without seismic protections perform similarly if high-strength infills are used. The seismic behavior of these figures show the infill frame that involves several factors such as the properties of the infill material, the connection between the infill and the frame, and the design of the overall structures. Here, in case of retrofitting techniques, in recently one example of retrofitting an infill frame structure is the seismic retrofit of San Francisco City Hall. After the 1989 Loma Prieta earthquake, the city hall underwent a retrofit that involved adding new steel bracing, strengthening the building columns and beams, and replacing the buildings with heavy marble cladding with the lighter weight panels. These measures help to improve the building seismic resistance and reduce the risk of damage or collapse in future earthquake. One important aspect of infill frame structure is the interface between the frame and the infill material. The interface plays a crucial role in determining the structural behavior of the building under various loading conditions. Here, in interface medium, as Muthukumar, the effects of several interface material on a naked frame and infill frames were studied. The finding of this research work can be used to guide future research into behavior of this interface material when subjected to seismic loading. An interface medium is a material that is placed between the infill material and the frame to provide a buffer zone and prevent direct contact between the two. This interface material, like the foam, rubber, or grout epoxy, can help to reduce the risk of damage to both the infill and the frame by allowing them to move independently of one another. So the infilled interface medium can be made from a variety of materials including rubber, foam, cork, and bitumen. So, benefits of interface medium to improve seismic responses, performance, and to reduce shear forces and to increase durability. The applications from the interface medium has been used in a variety of different types of infilled frames, including low-rise building, high-rise structures, and also be used in retrofitting existing structures to improve their performance. From the literature study, here is the summary of literature. Infills are active in earthquake loading, initial cracking propagated masonry, and follow to the RC structure loading lateral loading. The intervention which can alter the behavior of infilled frame structures. And in order to enhance the seismic performance of RC structures having infill walls, and to isolate the infill masonry panels from surrounding RC frames, some methods have been proposed. So here my conclusion is that the interface medium is a promising new technology that can help to improve the performance of the infill frame structures. The use of an interface medium between the infill and the frame can improve the ductility response of infill frame structures. So by providing a buffer zone between the frame and the infill, it can reduce the risk of damage and collapse during seismic events and other types of structural loading. However, in my area, further research is to require to investigate the behavior of infill frame structures using interface medium under different loading conditions. These are my reference.
Dinakaran.
Hello.
Mr. Dinakaran.
Yeah, yes, sir. Yes, sir.
Whether you started any experimental work to justify your topic?
No, sir. No, sir.
Okay, actually, you are the research scholar or a
Yeah,
PhD
yes,
student?
research scholar. Research scholar.
But
This is my review paper, sir, actually.
now only you completed the review, correct?
Yeah, actually, this is
What is the method you plan to do the experimental work to fulfill your project?
Yeah, I am planning to do the square infill frames, both experimental as well as
Please be louder.
Hello? Yeah. So, I'm audible,
Yeah, tell me, I am unable to hear you. Yeah.
yeah, okay. Actually, I'm planning to do a square infill frame in both experimental as well as analytical by using Abacus software, sir. So, by coming this April 2nd, week, I'm going to start the experimental work, sir. So, before then, I've completed all the mechanical properties that are all completed. So, major experimental work, I'm going to start in April 2nd.
Okay, ma, do
After
well.
my
Okay,
confirmation.
do well. All the best. Okay.
Thank you so much. Thank you.
Thank you, Dinakaran sir, for your presentation.
Thank you, sir.
Sir, Gopalakrishnan sir.
Yes, ma, I am waiting for
Sir,
you. Yeah.
remaining paper IDs were absent, sir. Shall we close
Okay,
the
okay.
session formally?
Yeah, you can close it.
Okay, sir.
Thank you, sir. We request all the participants to give your valuable feedback in the link provided. The certificate will be provided to all the paper authors within 3 to 4 days. Sir. The procedure for downloading the certificate will be emailed to you later. Now I invite Raghavan sir to present the vote of thanks.
Good evening to all. On behalf of Department of Civil Engineering and the entire fraternity of our institution, first of all, I extend my sincere thanks to Almighty for making today's session 2 on the domain structural engineering a resounding success. I extend my heartfelt thanks to our session chair, Dr. R. Gopalakrishnan sir, professor from Department of Civil Engineering, SRM Easwari College, Engineering College, Chennai, who spared his time to grace this occasion and shared his valuable inputs to the session 2 presenters over online platform. Thank you, sir. I extend my sincere thanks to our beloved principal, Dr. L. Kanesan, Vice Principal, Dr. S. Rajakarnagaran, and Dr. S. Dharmar, HOD of Civil Engineering Department, for their encouragement and constant support to conduct this session for our conference in a well-defined manner. Also, I thank all the presenters of this session for your active participation. Last but not least, a big thanks to all the participants, faculty members, and students who attended this session. Please fill the feedback form which is posted in the chat box. Thank you. Once again, I thank you all.
Thank you, ma. I am leaving, ma. Thank you. Thank you.
Thank you, sir. Thank you, sir.
Thank you for giving me opportunity. Thank you.
Thank you, sir.
Thank you, sir.
Participants kindly fill the feedback form. The feedback form link has posted in the chat box.